Hello. Morning.
Hello, how are you?
Wow, how are you doing, Alyssa?
I'm doing good.
Yeah.
Yes, I am.
Oh, good. Yeah, I saw your email and we can review the things. And then I was doing research on the triple. What was it? The triple and the twice. Yes. Remember there was the one here, let me show you.
Okay.
Um, oops. Okay, here. So remember the question was uh the plants triple in number?
Yeah.
Triple means three times.
Yes.
So I was like, oh, it's not exponent three. So it's not three times three times three. It's actually so we have the bananas that is three for the
Mhm,
first year, and
mhm.
it's tripled in each year. So times that by three is equal to nine. Then it triples again, which is 27. So the book is still correct.
Oh, yes. Yes. I think I have the book too.
Oh, good. Good.
Oh, 6. I bet. Oh, where did I put it? Of course. Yes, that is correct on that.
Yeah, yeah. So I was looking at it, I was like, oh, that's what it means.
I think I mean, like I said, when we did those problems,
Yes,
and you were able to show addition, division, and multiplication kind of at a very simple elementary level.
yes.
It was awesome to see it on your abacus. So we could see it on your abacus, but then when we went to the replay, or when I went back to replay, it I couldn't see you doing it.
Oh,
It didn't show it.
interesting.
It
Oh,
didn't
yeah.
show it.
It could be what? It could be that it could have been that I was traveling.
Yeah, I think it was your traveling, and that's why. And
Yeah.
that's why I asked if we could go over the problems again.
Yeah, not a problem.
I noticed you had like on the let's see, on the 2 weeks ago there was like 140 um uh people looking at it,
Yeah.
and so I thought, let's do this again so that they'll be able to see you writing out the formula that's being used, or
Okay.
they see you working the problem right there. Plus it helps me too.
Yeah. Let's be selfish and just say
Yeah.
that's okay. We could say that you're because if it wasn't for your questions, then we I wouldn't be doing it. You know what I mean?
Yeah.
So I'm perfectly fine saying that, yeah, if that's what you want to go, that's fantastic.
Yeah. And then yeah,
Great.
yeah, this is awesome. So for understanding a problem, did we read too much into it, or what did we not notice? You said the triple was the main key.
Yeah.
So where did you research that? What did you do? You just looked up what
I
the definition of triple meant for
Yeah,
math?
exactly. I needed to know what triple meant.
Oh,
That's what the problem was. Because I was thinking it was the exponent of three, but it's not. It is because twice is what? Twice just means two.
times, yeah.
So if we did three twice the amount is only going to be six. And then twice again would only be two.
Oh, so it's understanding the words in the problem
Yes.
to help us,
Yes.
we don't, so that we don't make a mistake or something. Well, it's okay. I mean, it's just really understanding the problem is what.
Yes. Yes, it is really much trying to understand the problem and that's why reading is really crucial.
Yeah, that totally makes sense. Reading is very crucial. That's and I'm not very good with story problems. Sometimes, I mean, there's some really easy ones, but this is. I came across the book. It was called um, Milne. The person, I don't know if it was from the person that wrote the Pooh or not, but there was some arithmetic problems in there, and he had addition, subtraction, and multiplication, and
Uh-huh.
it was I'll have to go look for it, I think, in my room. But it was fascinating, and the story problems that they had back in that time period. I don't know what the time frame was, but it was a really old book for arithmetic.
Oh, interesting. But you
Yes.
don't know the name of the book.
I would have to go and look for it.
Okay.
I could try to do that. But yeah, I'd have to
It-
go look for it.
It's okay. We can do it tomorrow or next week.
Yeah, we can do it next week. I will be prepared. I'll be prepared. And
Um, yeah, yeah, those are always good to go back. And it's interesting to see like how it was done back in the day and how it's done now. And I think we're losing a few steps with the new stuff in mainstream. Uh, yeah. And I don't know because it's, everybody's doing their kind of their own thing. Just like I'm kind of, spinning off from the actual abacus world because
yes,
I don't call it mixed formula. I call it two-step equations.
yeah, I like it. I like it being called two-step equations.
Yeah.
Um,
Uh, why?
and I was also able to solve that one three-digit problem where you had three digits of adding, and that one the email that I had sent. I was able to.
Yes, this one.
Oh my goodness, yes. So at first I was really overwhelmed by it, but then
Yes.
and I noticed when I go to the left, um,
Yes.
so 148, when I add the 148 to 382, I got 530. And so I kind of put an arrow and put 530 with there. And then I think it's just to recheck to make sure that I added those two right.
Okay. So, yes. Okay. So we add the three. One, two, three. Add the eight. Plus the eight is what? Eight is equal to plus the 10 minus two.
Mhm.
So I plus the 10. I'm sorry. Let me go back. Let me go. Eight is equal to minus the two plus the 10.
Yes.
Minus the two plus the 10. Cannot plus the 10, we know. Plus the 1 is equal to plus the 5 minus 4. Plus the 5 minus the 4. Plus the 2. Plus the 2 is what? Plus the 2 is equal to minus the 8 plus the 10.
Yeah.
Minus the 2 plus the 10.
Let me tell you.
Did I do that right? No, I didn't do that right. Minus 8. There we go. No? Yeah, that's right. So yes, you got 530. So then I would keep a running total, 530, and then I'd do plus 7, 5 like this.
Yeah, that's what I got.
Okay,
530
good.
plus 275. I I I I can't do it. That's horizontal, right? No,
It is
vertical.
horizontal. No, no, it's horizontal.
Okay.
So all you do is move it this way. Do you remember?
Oh yeah. Well, I'm so oh, it's big numbers. Yeah. I could do it vertical. That the 148 3 and you're doing yeah. It's good to do it both ways.
Yeah.
Um,
But so then what I do this.
that's easier.
Yes.
I don't know
Yes,
why
it is.
it's easier to do it that way. Cause see, it's right underneath,
Yes.
and then I'm not having to. Cause I'm doing each individual. You subtract, you do the one plus the three, and then I don't know why. It's just easier doing it vertical like this than the
Yes.
other way.
Yes. Yes. And I like it vertical as well, but I wanted to keep it flexible.
Mhm.
I don't put it in my books to do horizontal.
Mhm. Mhm.
And all of my stuff is vertical.
Vertical.
Yeah. And all the other abacus books are vertical as well. Only mainstream is horizontal,
Right.
which
Right.
is strange. But it would be a precursor, however, it would be a precursor to algebra.
How is it a precursor? Oh, because
because,
you have do
yep,
polynomials.
yes.
Oh,
So
okay.
algebra, right, is horizontal.
But
And
are
then
the
you,
numbers that big though? The numbers aren't that big when you're doing algebra, right?
no, I don't think so. They do a lot of single digits and maybe double digits. So
Yeah.
10 to the Z or whatever, or to the X or whatever. And then
Mhm.
plus 32. I don't know. I don't know too much about algebra questions, but I do remember that algebra is horizontal. So it
Mhm.
could be that.
Yeah. My other question, when you're doing this problem, why are there less formulas when you go left to right, or is it just with this particular problem? Because are you supposed to have the same amount of formulas when you go from left to right versus right to left? Or are they gonna be, that's what I noticed, it seemed like less steps when I went left to right um, versus right to left. There seemed to be more steps when you went right to left with that problem.
This specific problem, it's because of the numbers. So the numbers, if you go from left to right, sorry, the formula is going from left to right is going to always, not always, but it will be different from going from right to left. And it just happens to be this specific problem. Because sometimes going from right to left, there's less, there are less formulas. However, I feel like you go one step back and then two steps forward, kind of a thing. So that's what I feel like when I go from right to left.
Okay, okay.
Does that,
But
so
aren't you
because
kind of doing that when you go from left to right? Because so you go 1 plus 3 and you have 4 there, right? Then you go to the 4 plus 8, and the 8 is plus the 10 minus the no,
two,
minus
yeah,
the
plus
2.
the, yeah,
Then you go back and you have to go plus the 10.
right. But
Um,
10 is 1 0.
oh yes, you're right. It is 1 0 because you have to do plus the 1 equals plus the 5 minus the 4.
Yeah. And then this would be the 0. So you're still living off of going forward. You're still going left to right.
Oh, you're still.
Whereas, yeah, so like if you did the other way, 1 4 8, right?
Mhm,
So if we
mhm.
did 2, we got to go plus the 10 or minus the 8 plus the 10.
That's
So plus 10 is 1, right? Plus the 5 minus 4, and then it's 0. Then I got to go back. I got to go here. You know what I'm saying? So with the 1 and the 0, you're here.
mhm,
That's what I think. That's a theory. I don't know.
mhm.
Um, because it's 1 0. So then I have to go back here. Okay, I got to add the 8. To add the 8, it's plus the 10 minus the 2. Minus the 2 is minus the 5 plus the 3. And then I go back plus the 3. Plus the 3 is plus the 5 minus the,
Minus the 2.
yeah.
Yep. And that's where with adding all that you get 530. I
Yeah.
mean, do you just continue going on with the next one, or is it good to kind of do a recheck with those first two numbers and put 530 there? I mean, would you recommend doing that?
I would recommend putting a running total like this. I wouldn't check it.
Okay.
I would wait till the end.
I see, I see. So the running total, now why would you suggest to put the running total? Is it to just make sure you're on track or what?
If there was a mistake towards the end, then I would do it again or I would start checking.
Oh, okay.
So it would be more like it'd be more like what? It would be more like trying to figure out um if if I was wrong, where did I go wrong?
Hmm.
You could, I mean, you could you could check as you go, but then you disrupt the flow when you add as a
Hmm.
whole,
Hmm. Hmm.
right? And
Okay.
it still disrupts when you write out the formula as well. So ideally, I just want to be able to plus the 2 plus the 7, um, right? And then plus the 5. Ideally I just want to do that. But because if we're still learning, then writing out the formulas would disrupt the flow.
Oh, and so when you're doing that, because you know the formulas, you just verbalize the formulas and
Yes,
continue going on until you get the answer.
exactly.
So
Exactly.
that's, so do your students get to that point
Yes. Yes.
and they don't write it out anymore?
No, they don't write it out. When they get to 3 digits like this, they don't write it out because they've done the 1 digit, they've done the 2 digit, and because of the constant practice, they started to see and they start to go through. That's
Oh,
that's the goal. The goal is that they don't write out. I mean, we're the reason why I'm writing now is because I'm pushing you forward, right? But
uh,
if you had the practice doing this, would not we wouldn't need to do all we would not need to do all of this.
oh, wow. Okay.
Does that make
Okay.
sense?
So, so basically, for example, okay, so I'm teaching Abram. The the more he practices just the single digits,
Yes.
he's gonna pick up the pattern
Yes.
that when he goes to 2 digits,
Yes.
then he'll know it.
Yes. Because it doesn't matter which column you're in because it works exactly the same.
Hmm. Okay.
So that's why we do the single digits, get them used to it, and then when we expand it, it would be easy because it doesn't matter if it's 5 digits, 10 digits, or 13 digits. It just matters to make sure that you properly move the beads.
Oh, wow. So it is a gradual increase of the problem, making it
Yes,
get bigger each time.
yes,
But then when you do the two steps to even as just two single digit numbers, it's
yes,
becoming familiar with that too as well.
yes.
Okay.
But you're getting used to it too. You're seeing that when I have to do 4, right, and I need to add the 1, you're already seeing that I have to add the 5.
Yes, I am.
So time, exponential that to across the board. When you go into 2 step, you can see it,
Hmm. Yeah.
right? And so even when you're going through it and you see the revelation, you're going to see that it gets easier because you know the formulas. But it goes back to how solid are you with your formula.
Okay. Okay.
That
And that's why you really practicing and practicing and practicing.
Yeah,
Okay.
because once you know those 2 sets, then everything adding, subtracting is all there.
Mm. Now, why is it hard with the division though? Is it because you have to know on the abacus where to put the quotient? Because
Quotient.
yeah, the quotient and the dividend, it's because there's so much your eyes have to keep track of on the abacus, and so I get a little boggled.
it's it's not, don't forget it's a progression. We're jumping through a lot faster than the class. So
Yeah.
you're trying to understand how to do the division and you're also trying to understand how to do the adding and subtracting.
Hmm.
But see, in division, when I'm going to when I introduce it, it's not, I see what you're saying.
Hmm.
What is it? It is, let's you know what? Let me find a problem.
I'm wondering if I on my abacus, because okay, I might get another abacus like Abrams, and maybe I'll just order through you, and you can put a lease on there because I got the brown one, right, but for some odd reason I don't like the color of the brown one. I really like this colorful one,
Like
but
the brown one is good because you have space.
mhm.
So we can practice with the brown one. I just got to find my here. Oh, there it is.
And I'm wondering if I need to like put it like a marker to just a different color or just so I can keep track, you know? Um,
Yes, yes, because you're still getting used to the columns.
yeah.
It could be that. Yeah.
The bigger seems a little overwhelming in some cases, and that's why I like the smaller one. And I
Yeah.
figured my problems right now, I mean, what's the biggest problem can you do on there if you're dividing?
This one, it would be probably 3 digits minus 3 digits time divided by 2 digits.
That's pretty good though. I mean, in elementary math, what's the biggest division problem are you doing? Probably not 3 digits. In
Uh,
you know,
I
like
I think they go to 5 or 6, but that's like in grade uh 4.
for dividing?
Yeah, I think so. I think they're making it more.
Really?
Yeah.
Okay, then that would be too small.
Yes, yes. He would have to graduate to the bigger one when you get used to it.
I see, I see.
So, yeah.
Well, how about we go through some more of those questions? And then when we
Which
get to a division, we can, put it depending on the type of question.
wait, I'm sorry. You want to do division or you want to go back through the questions from last week?
I want to go back through the questions, the story prompts last week,
Okay.
and then because it does show you a little bit of division in there.
Yes,
And then we can talk about division because it does
more
multiplication
division.
and division. So
Yeah. And so yeah. Okay. So here, uh if you're calmly riding your bike at 14 miles per hour, but your horse starts pulling you twice. See, there's that word twice. Oh, I should. What am I doing? I need to highlight. So, yeah, I think that was the one problem. Like, I wanted to make sure that I added story problems to my books. So we have twice as fast as that. So twice means what? Twice means times two.
times two. Okay. So then you have 14 times two.
So then I would have, yes, because it's as fast as, right? So because we have those as well, we know that it relates to this 14. So I have my 14 on my abacus. I'm going to, because I know my question is 2 digits and 1 digit, you add those digits together, you get 3. So 2 plus 1 is equal to 3 digits. That means I'm going to be somewhere in the hundreds column. We have to count the amount of digits. So that's the difference between mainstream math and abacus math. We actually look at our question and we try to project where we're going to start.
I noticed that they've been projecting with multiplication by kind of, what is it? Guessing what the number is by, I don't know.
Oh, yeah, that's like an estimation.
Yeah, they do estimations. Um,
Hmm. Sorry,
it,
estimation or approximation.
yeah, approximation. So is that a good thing? What is the purpose of doing the estimation approximation?
I don't know. I assuming it's because they want the kids to understand the numbers and how close you can get it. But I I in my humble opinion, I think that's the wrong way.
And why do
Because
you
we
say? Does it cause confusion?
to do the approximation, does it cause confusion?
Yeah, so why do you feel that's the wrong way? Just explain what your thoughts are on that.
Because it's hard to know what 2 times this number is.
Couldn't you go 2 times 10?
If 2 times 10 is 20,
Right, so we
but it
know.
doesn't look like, well, we could. So we have 20. I don't know. I I don't see. I think they're trying. What I think they're trying to do is they're trying to fill the gaps as opposed to actually understanding what we're trying to do. So in abacus world, we kind of know we're somewhere around the hundreds because we have 3 digits. That's it. It can be
How do
higher.
they
It can be
talk
less than.
about, so they don't talk about that this is going to be a 3-digit problem.
Exactly. You don't know if this is going to be a 3 digit or a 4 digit. So if I did like 83 times that by 2, so they just say, oh, it's going to be, if you round it, it'd be 80 times that by 2 is like 160. So you're going to have 160. But they don't talk about place value.
Oh, they don't?
They don't, no, they don't talk when you're rounding, when you round like this and do approximation, you're not really talking about place value. You're timesing it out. I'm looking at this question. I go, oh, I have 3 digits. I'm going to be roughly about, 3 digits, but let's take a look.
Oh,
I don't know. It's a very small nuance.
so then are you missing a principle when you're doing it, where you're just doing an approximation there? You're missing the principle of place value, is that what you're saying?
Maybe, maybe that they're missing it. I don't know. I maybe it's just another way for the kids to, I don't know, get another strategy for the kids to understand.
Okay.
Right. So that's the other thing is like they like to really clutter the amount of strategies for the basic arithmetic as well. Do we really need the strategy? I mean, that's the other question. What's the point of having this strategy? Just like learning doubles, like 4 plus 4, memorizing doubles. We had to memorize our doubles. Why did we have this strategy? I don't know. Because we were tired of counting up. 4 plus 5 plus 6 plus 7 plus 8. We were tired of counting up. So we just memorized. So what does this approximation do? I don't know.
Yeah, I don't know either.
But that's the thing, like I don't know who introduced it and what's their because it's like telephone. Like the person who thought of this might have had a really good reason. But as we go through the telephone, we don't know the maybe we don't know what the true reason is because it depends on the messenger,
That makes sense.
right? And so that's why I can't I don't have an opinion on this because I don't know what the purpose is for this. I feel like from what I'm hearing that it is another strategy that will just because they're like, oh, kids learn differently. Yes, they all learn differently, but we all know our alphabets: a b c, abba, buzz, ka. You know what I mean? Like the phonics of no, the phonics of letters. Why don't we do that same thing with numbers? Why is there so many? There's like tons of strategies. But if you bring it down to, I feel like if you bring it down to the elementary, the most manageable chunks, then doing this and we do distributive property,
Yeah, that makes
right?
sense.
So like here, you bypass the concept of distributive property. I don't know why we would need to approximate. Because if you know the answer, then you can round the answer. But they're very focused on the answer. They're not focused on the process. I don't know. That's how I feel.
Is rounding the answer and estimation the same thing though?
Rounding. Well, I guess it depends on what kind of operation. Because I think multiplication is way bigger than adding, right? Because 83 times 2 is way bigger than if I said 88 plus 9. Because this would be 90 and then this would be 10. So the numbers are closer. But if I did this 90, like I don't even know how to estimate 90. Oh, I guess I did. But it would be like 90 times 10, right? Or would it be 90 times 9? I don't know. I don't know. I think it goes back to I feel like that there's a complication here that doesn't necessarily need to be.
Yeah. Sometimes simplicity is best.
Yeah. Yeah. Sometimes it's too much information, right? Sometimes too much
Bad that we
information.
get bogged down and then, yeah.
Yeah. So then you don't leave your mind open for other things like, higher concepts.
Or you'll be confused and won't understand the higher concepts because you've gone at an elementary level and made it. Sometimes too many options
Yes.
can be can too many choices can be too, you don't, I mean, we're learning about the abacus because that is another way of learning. And I think they're doing the same thing too, but you're talking about the principles of adding and subtracting. And I mean, this is the first time that I've realized, by knowing the partners to 10 and knowing the partners to 5, how to utilize it instead of kind of going the round way of knowing your facts.
Yes.
And you're using them and you're actually visualizing and seeing it. And so that's why I guess that's why I'm intrigued by this.
Yes.
And
Yeah.
it makes a little bit more sense. But because you're being taught some other ways, it's kind of like spelling. If you understand the patterns of words, um, then you will understand the rules of the words, when you understand the meaning of the word, maybe spelling the word might be a little bit easier, instead of taking some words and then you go and you try to memorize it and you cover it up and then you go and try to write it out on your own.
Yes.
But if you're using the word in context in a sentence and you're and looking it up, you might be able to remember to spell the word that much easier. And I think that's kind of like the same about this math. You're utilizing your numbers. You're not just, because I remember when I was helping with Avram, um, he got to know, well, 2 plus 3 is 5, 4 plus 1 was 5,
Mm-hmm.
and that's all he knew.
Mm-hmm.
That's it.
Mm-hmm.
And then you move on.
Yes.
But here you're showing how to utilize that.
Yeah.
So yeah.
It so the difference, and I was trying to relate it, and I think the difference is when you do the math facts of 4 plus 1 is equal to 5, and then 2 plus 3 is equal to 5, and then I think that's it,
And
right?
you
And he had
reverse
to,
it.
and then you reverse it, right? So yeah, oh, that's right. So just knowing this is fine, and yeah, in advocates we actually utilize it. But if you ever get a chance to, there is this one documentary called The Truth About Reading, and they talk about how some people are like millionaires. It's crazy. A millionaire was unable to read. He was illiterate. Like he was, and he was old. He was like probably 60 or something. And it was crazy on how he was able to go through life without learning how to read. What they did, and there was another lady, she was like a C-suite, like a CFO or whatever. She didn't know how to read. There was a teacher, an English teacher, who graduated to master's degree and still didn't know how to read. And so he was able to just bypass the system. And I'm like, how is that even possible? So what they did is exactly what you said, is they memorize certain words that go together, and then they try to mesh the two. And so when the CEO was trying to write a letter, an email, she would go to Google and she'd be like, okay, I'm looking for the word manager, but I think I remember there's a G somewhere, and I remember that there's an M. So I have to figure out what that word is. And so she would put in like an example. This is where I'm going to talk about, and this is how I'm going to do it. And because she said it that way, and she's illiterate, I feel like that's the same correlation what we're doing with math. We're teaching the kids to be illiterate if we focus on the result and not the process.
Yeah.
The, right? So it's always going to be the second number in abacus world that dictates whether or not we use the formula or not.
Yes.
Right? Yeah. And it was very interesting. If you get a chance, it was The Truth About Reading. It blew my mind when they were talking about it. And I mean, obviously they felt ashamed because they didn't know how to read. However, they when they finally figured out to read, it was such a
Relief.
yes. And there's this one man, he actually saved his love letters from his girlfriends, and he just, you know, kept it for like 50 years because he couldn't read it. He finally was able to read it. It brought him to tears. Oh my God, it was so good. It was so good. Yeah.
Oh,
The Truth About Reading. It was a crazy documentary, but if you get a chance to, if you can, I feel like this Truth About Reading is very much aligned with math illiteracy.
ah, yes.
And I feel like, yeah, we teach the counting up, which is what mainstream does, but then we don't teach there's no other ways. They just do counting up. But in Japanese, they figured out the system to utilize the fact family. You know what? Even the Chinese abacus, I was in a live, and somebody actually knows how to do the Chinese abacus. They do counting up as well. And I'm like, how is it possible that you're doing counting up and not a formula? So I think the Japanese soroban, this Japanese abacus that we've just done, I think is a new, like, I think it's relatively new, like since 1970s or 1940s or something. Whenever the soroban came about, that's when I think the Japanese was able to understand how to utilize the I have to go back to my history to see when the soroban was made.
So how were these formulas created?
I think somebody was able to see it and be like, you know what, we can just isolate the variable, which is what algebra does. So if I want to isolate the variable 4 plus 1 is equal to 5, they need to isolate it. It's like algebra, right? You cancel out -1 -1. You cancel this out, right? It's 4 is equal to plus the 5 -1.
And how
But
did they know that it would work? How did they know that it would work? Because these are just numbers, you know. Because I don't know any other. Because we're learning base 10, right? And I guess there's
yeah,
other different types of bases, but we're applying it to the base 10. I don't know if the 5 is a base 5, but so we put this formula in, and it works every single time without fail.
yeah.
So how?
I don't know. That part I don't know, like who quote unquote invented or found out or what have you. So like even in school, we know that 7 plus 3 is equal to 10 because the decimal system, right? We are on a base 10 system. Making of the 5, making of the 10.
Oh,
I
the
don't know
making
how.
of the 5 is also on the 10, on the decimal system, the 10?
Yeah, yeah, yeah. Yeah,
Oh,
it's just the half of 10.
okay,
Because a base 5 means you're only doing 5, 4, 3, 2, and then 1.
okay.
Base, but I don't know how bases work, but I know that we are on the decimal system and the decimal system is a base 10.
What is the decimal system like when you're teaching? What is that concept?
Decimal means it's just a 3.25 decimal. Anything after the ones place is considered decimal.
Oh,
And
yeah,
decimal, the word is 10. Des is 10.
deca, like that, yeah.
Deca, yeah.
Okay.
So this is a base 10 um, numbering system.
What does the MAL stand for?
I think it's just a translation in the making into English,
Because
maybe.
the AL is basically a suffix.
Right, right. Yeah,
So,
yeah. I think it's just, as English comes around,
yeah.
because we have to. Yeah. So like, it's the interesting thing is like in Chinese, we don't say 20, we don't say 11, we say one tens, one, 10, one tens, 10, and then one, two. So 21 is like two,
2 and 1?
two and one. Yeah. But we know it's two tens and a one. So we actually break it out in Chinese, but that's Chinese. I don't know how they work. I don't know how they count in Japanese.
I think they do the same, like two tens, two
Yeah,
tens. They
two
say
tens and
yeah.
yeah, two tens and two. Yeah. So it's different. Yeah, it's just different. But in America, I mean, it only starts with a 20. 20 is our tens. But the word 20 doesn't make sense.
There's the T, there's the T part. What does the TY stand for?
I don't know. See, 20, I don't know where they get 20 from, or even 30, 30.
Well, thir, PHIR is three. And I think the
The
TY
TY is a tens,
the 10. Yeah.
50, 60, 70, 80, 90. Yeah,
Yes.
I guess so. Yeah.
That's what that T part means.
Yeah. Okay. Yeah, I like the entomology of stuff. That's very interesting.
Yeah.
So it could be AL just means system. I don't know. I would have to look that up.
I'll look it up too.
Oh.
So yeah, because I meant to tell you about see if I have it here, about the adding thing. Person. Yeah, with the word addition and subtraction is where you're putting the lesser
Oh,
number below the
right.
higher number. Uh,
Oh, right.
mhm.
Okay.
So,
Um
yeah, I meant to get that ready for you the last time. And of course I misplaced it. I think oh my goodness, where did I
that's
did?
okay.
Yeah.
Well, when you find it, just shoot me an email and
I'll
then
shoot
I'll,
you,
I'll
I'll shoot you, uh, I know, let's see. I know it's missstevensclassroom.org, but I'll shoot it to you. But
okay.
it's just really interesting. But yeah, like I said, I mean, obviously this formula works every single time.
Yeah, it's
Every time.
crazy. And it's interesting because even when we do the plus 10, we're only working with 10. We don't work with 20, 30, or 40 for the next number over. We're always taking away the 10.
Yeah, you do that in every place value, right?
Yeah. Yeah. But then in mainstream, they have this whole like strategy on how to do a subtraction, but they don't break it down to the basic of the basic. So
That's
did I
why you
show
have
you?
to memorize and know the facts.
Yes, yes. Did I show you that?
You can show it. You might have. You can show it to me again.
So if we were doing subtraction, this one.
No, I never saw that.
Oh my God. I started breaking this down and I was like, oh my God. So
Where did you get that?
I I made it.
Oh,
Yeah.
okay.
I make most of my I get inspired, but I make all of my worksheets. So in mainstream, you have to borrow. That becomes one. This becomes 13, right?
Okay. Yeah.
So what happens? You need to memorize your math fact that 9 plus 4 is equal to 13,
14. Yes.
right? But in Abacus, you just need to know this. Minus
Yes.
the 9 is equal to minus the 10 plus the 1.
Yes.
That's it. But you have to memorize this. Oh, yeah, we've talked about it. I remember we talked about it. So we did
I've just
20.
never seen it. I've just never seen this form like you did. Is this something recently you created?
Yeah, but yeah, about a couple of weeks ago.
Oh, wow. Okay. So
Because,
that way you're able to see. Oh, I like
yeah,
it.
thank you. So we take away, so in Abacus world, we take away the 1, we take away the 9. Minus the 9 is minus the 10 plus the 1. So my final answer is 4, right? So this is the difference between mainstream math. And then we have to do it again, right? We need to know why. Because if I'm going to minus the 9 here, I'm going to make this a 2 and I got to make this 15. What is 15? I need to memorize 9 and 6 is equal to 15. That's how I get it. Or you memorize 9 minus the 9 is equal to minus the 10 plus the 1.
And so what's cool with this minusing the 10, you see that you're subtracting,
The 10, yes.
yeah, you subtract because you have 23 On the abacus,
20, no, 35,
oh, sorry,
35,
35,
35.
okay? And you see that there, and then your
Take away the 2.
take away, yes. Take
So we're
the,
at 15. And
yes,
then now we're going to minus the 9.
yep, because you'll minus the 10 right there.
Yes. Yeah, well, minus the 10. Oh, yeah. So then
And then you have
minus
plus
the,
what, and there's your 6 right there
uh-huh.
in the circle right there.
Yeah, yeah,
That
exactly.
that shows you that shows you the answer within the. Okay. Well, I might be
Yeah,
thinking a little bit differently, but
you got it. You got it. But see, what I guess maybe I shouldn't be so close in the numbers. What I maybe should do this one, right? 86. So 86 on the abacus. So we have to take away 7, and then we have to make this 16. To make this 16, I need to memorize that 9 and 7 is equal to 16. So we have to take away the 5, right? Take away the 9. Minus the 9 is equal to minus the 10 plus the 1. Minus the 10 plus the 1. I don't need to memorize that this is 7. I just need to memorize this and move my beads.
that makes sense.
Right? You have to memorize but in abacus, we only need to know what this 9 is. But in mainstream, you need to know this, and you need to know this, and you need to know that. Right? So there's 3 things you need to know, remember, memorize, as opposed to understanding how to utilize. If I want to take away 9, what's another way to do it?
Repeat that question again. What's another way to take away the 9?
Yeah, what's another way of taking away the 9? As opposed to memorizing that 9 and 7 is equal to 16, because we're doing addition here. We need this, we're finding the missing factor. So this is 9 plus what is equal to 16. You need to know your you need to know your addition facts.
That would be in 7. Yeah.
Yes, right? So that's why they do the missing factor in addition sentences. But I don't think this is where I don't think this is a good use of energy because you have to know what your answer is, right? Whereas in abacus, you know the process. This goes back to the concept that you have to memorize or know your result. You have to know your result.
Yes. Yes, you do.
Right? So we could do it again, right? With hit this one. So we have 47 on the abacus. I take away the 1. Again, mainstream, you have to borrow, and that becomes 17. Well, how do we get 17? 17, we need to memorize that 9 plus 8 is equal to 17. But in abacus, it's minus the 9 is equal to minus the 10 plus the 1. Minus the 10 plus the 1. So my final answer is 28.
28, yes.
Right? So I feel like it's efficient and less energy to memorize how to minus the 9 as opposed to memorizing what 9 and 8 is, because don't forget, once we know this, we need to know it for the not for the 8s. So there's the math fact. Where's the other people? So there was a So there was a YouTube video. A teacher was like, "We need to memorize how to make an 8." I'm like, "Why?" So here, 8 plus, I'm sorry, 1 plus 8. I can do it. 1, 5, 6, 7, 8. Bring it together. I don't need to memorize it because it's already here. I don't need to memorize this. And they go further, right? So then they go to, I don't know. So the next one they do, right? They need to memorize. They need to start memorizing all their math facts all the way up to 20. Like, what? So they need to know 11 is equal to 9 is equal to 20. And then they got to go like 12. I don't know. Is it 12? anyways, I'm just kind of they go backwards. 9 is equal to 19. And they need to know 9 plus 9 is equal to 18. And then they need to know 8 plus 9 is equal to 17. They need to memorize all of this. Because it's the fact family of 9. I'm like, what? So
okay.
Does that make sense? So yeah, they keep going. They need to know that this is 16. And then because they know the 9s, they got to do it again for the 8s. 8 plus 8 is 16. 7 plus 8 is 15. 6 plus 8 is 14. They have to memorize, as opposed to Abacus World, we just need to know that.
Yeah. Huh. Yeah. Yeah. I always say whenever I'm adding a 9 to any number, I said 9 wants to be a 10. So 11 plus 9 is the same as
Yes. So that's the one thing in mainstream math is like, okay, well, how do you make this a 10? So you need to plus the 1, but they randomly add the 1, but they don't take it from the previous number. They just, you have to memorize, you have to remember that you added a 1. So when you come here, you have to take away the 1. So let's say with this one, it was 11 plus 9 is equal to something. So they're like, okay, I want to make this a 10. So we do 11 plus 10 is equal to 21. Oh, I remember I added a 1. I have to minus the 1. So then you have to, So then you have to go 20.
they showed it that way in a problem one time.
Yeah. Yeah, one of my friend was like, that's one of the things that the higher ups was trying to say. This is, and there was a whole teacher training on that. So this is rounding. This is what they're doing. They're rounding, but they have to remember what they rounded it to. And I'm like, what? That's very complicated.
So with the abacus, with your formula, you're talking about balancing because plus the 9 is plus the 10 minus 1. So you
Yes.
are subtracting.
Yes.
But so what would be the difference?
So if I did this, I'd have like plus the 9, right? And what do? We're actually doing this. We're taking the 11, we plus the 10, and we take away the 1, all in one area. And when you line it up, so we have 11, I have 11, I add the 10, and I take away the 1. So it's combined.
Oh, I see. Okay, I see. You just took the formula.
They made it vertical. Yeah.
Made it vertical.
Yeah.
Okay.
I don't.
I cracked a little bit. I cracked it a little.
What was the question?
I remember you doing this before. What is doing it vertically that way? What is that?
What does that do? The reason why is because then this lines up.
Oh, okay. Okay.
Right.
Because I see that because when you have that plus 9 and you go plus 10 minus 1, I see that that's part of the formula. So the 11.
Yes.
Oh, because 11 is the number that you're putting down.
Yes. That's the question.
That's the question. That's the first.
Yeah. So we substituted this into 9.
Okay.
So even if I don't know, 48 plus 9, right? So what do? We're taking 48 plus the 10 and then minus the 1. That's what we're doing.
Yeah.
Right.
Well, that's why you get 57. Okay. Yeah. I see what you're saying.
Yeah. But the difference is in mainstream, you get 48. Well, what do you do first? You add 2 here and you add 1 here, you'll get 50 plus 10 gives you 60. Then you have to remember, okay, I added here, I got to take it away, -3. So it's 57.
So it's just extra steps is what you're
It
saying.
is extra. Yeah, I feel like it's extra steps and more strategy to something that they should have just understood the fundamentals.
Okay, so just work with what you got. Don't round everything up to 10 and then take away. Because
Yeah.
if I were to do it, then what I would do is I would just circle the 2 and the 1 and know that I would have to subtract 3.
Yeah, exactly. Exactly. But see, that's the difference between what? The difference is you have a piece of paper that the sky is the limit. You could draw a tree, you know what I mean? You can do anything on a piece of paper because there's no restrictions. Whereas on the abacus, there's a restriction. So it's easier and we're confined. Just what do they say? They say, when you put a schedule, you have more freedom because you know what to do with it. Right? You've
Right.
heard of that. If you put everything in a schedule, then you actually know where all your freedom is and you have a lot more time to do whatever you need to do. It's the same thing with the abacus. It's like life. It's, you put a schedule, you put some restrictions, like just like rearing children. You put a boundary, they will have more freedom because they know where the boundary is. They'll push it. I'm not going to say they're not going to push it. They're going to push it, but at least they're still safe within their realm. Because if the sky is the limit, if they just let to do, they could play in the streets and there's no consequences, then they're going to continue to play in the streets and, something's going to happen to them. You know what I mean? But if you say, hey, there's a boundary, don't play in the streets. Okay. Why? Well, because it's dangerous.
So the boundary is the formulas,
The boundary is the abacus.
the abacus.
Yeah. So if I look at it and I want to add 7, I know I cannot add 9. I need to use the formula because I have the boundary that I cannot add anymore.
Aha.
That's why the abacus. Yeah.
Okay, and also you only have as high as 9.
Exactly. And it's the same thing. Even on regular writing it out, we only have as nice as high as 9. But because we're writing it out, our brains cannot see this because it's two-dimensional. Even when I make a picture of the abacus, right? Doing this, it's very hard to understand and see. But if I put it on my abacus, oh, this is 10. Right? Even as a picture, it's harder to see.
Yeah.
You want to talk about something else. That's why I'm muting a lot.
So, I mean, that's all right. I can fill it in. But then that's the difference between writing it out on paper because it can be anything and everything. You just don't know. It just all depends on how much time you have. You know what I mean? And so being able to put some restrictions helps create what? I don't know. Also provides creativity because even when even like streaming and stuff, like I'm trying to figure out all of my tools. I'm trying to figure out what tools do I have? Well, how can I make it work the way I want it to work? And it's the same thing with the abacus. So I feel like it's kind of, I think it's very similar to real life. Like, even clothes. Well, I want to make my clothes, but what is it made out of? It's either made out of cotton, polyester or whatever. So these are all the materials we have. The sky is not the limit. We are limited to everything that we're doing, even our computers, making it out of plastic, making it, making parts, out of gold or silver or whatever. We have restrictions on everything we do. Why don't we put that on math?
I see. Yeah.
Right? So even talking and if I said blah, 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 it doesn't make sense. That's what it is on a blank piece of paper. If I just tell you a bunch of words that have no rhyme or reason, then what would be the point? I'm just going to make I'm going to make my own quote unquote science behind it, as opposed to having it structured and then everybody, so it took a while for everybody to get the numbers from 0 to 9. The actual concept of 0 to 9 took a very long time. And this is the decimal system, because what happens after 9 is 10, goes back to 1, and there's a 0. This is still 1, this is still 0. If you and I keep thinking about it, it's like the actual decimal system itself is very elegant, and it provides everything what we are doing right now, or maybe we were able to feed into it. I don't know. It could be a the chicken or the egg kind of a thing. But the actual decimal system is very interesting, and it too has its own restrictions. So if this has restrictions, I don't understand why we don't do it as we add and subtract as well.
What restrictions does the decimal have?
You only go up to 9.
Oh,
I can't,
okay.
I can't give you this, and this is not a number. You know what I mean?
Mhm.
There's restrictions to there's only 0 all the way to 9. That's the restriction.
So then you work with the restriction that you have.
Yes. So what do? I need double digit. Guess what? There's our double digit.
Okay.
Right? We
Okay.
work with what we have.
I like that. Okay, that makes sense. And that's why the formulas work.
And that's why the formulas work. Because it sticks within the restrictions. It sticks within the ideas of, yeah, I think understanding the formulas, I think understanding the formulas really benefits, is really beneficial. Yeah. Yeah. People keep asking me, I mean, is this all you think about? I go, I think so. I think this is all I think about, because I think we're overcomplicating something, and I'm trying to debunk it as I go. But I'm not a mathematician. I'm just an abacus teacher. And I just really believe that abacus, I really do believe that seeing our numbers, abacus doesn't tell us what the formula is. We have to conclude to use a formula. So if I want to add the 9, this doesn't say, oh, you need to add the 9. This says, oh, I have 2. That's all it's telling you. But in your mind, you know that you're going to need to add the 9. I need to use a formula. That's why there's critical thinking.
So is it like
I'm sorry. Is it like what?
I was wondering if it's like hypothesizing.
Can I talk about my part?
No, you
It's kind of like hypothesizing. Um, yeah, yes, it is. It is hypothesizing. You're absolutely right. Yes, because I want to be able to add the 9, but I don't know how to. I know there's a formula. So in my mind, I'm going to use plus the 9 is equal to plus the 10 minus the 1. But we're only moving the beads. Plus the 10 minus the 1 is different than the abacus just shows me what I can do. I can see that I have 11. Now, what can I do? I can add an 8, 5, 6, 7, 8. I can add a 6. I can add a 5. I can add 1, right? Because I can see it now, as opposed to having just numbers, right? If I just had the numbers 1, 2, I don't know what that number is. If I did dots, you could do dots 1, 2. But in mainstream, you don't do it this way. Mainstream, you do 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or you do the stick. Even the stick does not translate the amount of dots you need. But see, the human eye can only see items of 5, maybe 6. That's why abacus is beneficial, because I can see 1, 2. I can also see my place value. I can see the positioning of my value. I see this is my 2 in the ones place, and this is my 1 in the tens place, which is very different in mainstream.
With the mainstream, you would have to do subsidizing, or you'd have to do grouping.
Yes, you would have to group it.
Or count it individually.
Exactly. And so I think the difference, and I think that's where we stay in the elementary, quote unquote elementary, that we're always either counting up or we're grouping. And that's why, I don't know. Yeah. So like this is 10. I grouped it into 5 and 5.
You can visually see that though. You know that.
Well, but if I do this, I have to rearrange it. You know what I mean?
Yes, you do.
I'll be like, okay, I'll do 3s. We'll do 3s, 3. Oh, this is 9 because it looks like 9. But see, that was the other thing they're doing. I was reading this one thing, and they're like, if you get something scattered like this, you have to get the kids to know how to supertize. I'm like, what are you what? Why? So like, well, they have to come up with how to group it themselves, and they would have to figure it out. And I'm like, this book was for kindergartners, and I'm like, you expect the kindergartens to know how to group it? I don't even know how to group it. So I could do this, right? But this is blocks. Whereas they were talking about on a sheet of paper. So on a sheet of paper, you would have to draw things. And I was like, oh my gosh. But even when you group it, if I group it like this, right? That's not even, I would have, maybe I'll do 4s. Oh, there it is, 4 here. I don't know how this helps supertizing. I don't know how this helps supertizing.
4 kind of represents a square.
Yeah, but I don't know why we need to supertize a group like this. You know what I mean? But like, this is not a square. This is more like a line. But we can see this because our eyes only see more than 5 things. So if I did this again, right? Our eyes can only see groups of 3, 4, or 5. Once you get to 6, right? When you get to 6, your mind starts to split them up. Oh, I can see this, right? See, our eyes already groups it. So when I do this, what do we do? Oh, maybe I go this way. Oh, you know what I mean? So our mind already groups them, but I don't know, like, I don't know if I did this. It's a practice of grouping, but it still goes back to like, it's hard to tell. I don't know why we would need this skill.
We'd still have to physically group it. I mean, my eyes see 4.
Yeah.
5, 9, and well, actually, I see 5 and 5.
Okay.
5, 10. There's 16.
Yeah.
There's 16, right?
Yeah, I think so. There's 5, 5. There's 17.
I was off by 1.
Oh, sorry. That was my fault.
No, I did pretty good, But
Yeah.
I'd have to physically circle it, or I would have to physically put it in groups of 5.
Yes.
And
yeah. But see, if you're in a classroom of, like, say 25 to 30 kids, that's a whole lot of blocks. And you can only go up to as many blocks as you have. Whereas on the Abacus, we can go all the way to 10,000 and it's organized. Oh, that was the other thing. My friend was talking about how it's hard for a child that has ADHD and doesn't know how to organize. You do this, they'll do something and they don't know where they're at. Whereas if you do this, you walk away, you come back, you're still at 10. So I don't know. Yeah, he mentioned he did mention, like, it was for those children that have ADHD, it's harder to deal with blocks because they don't have organization skills as well.
Oh, okay.
Yeah.
Whereas this is in a frame and
Yep.
you're limited to so much you can do in it.
Exactly. Exactly. And I think that limitation helps more freedom.
Okay. I like it. I like it. Well,
That's
should
why
we
we're
try
here.
a couple of more story problems?
Yeah. So I was at the 14. I was going to do times 14. If I can find my paper. Because I put my papers all over the place. Yeah, it was 14 times that by 2. Oh, here it is. So 14, we're going to count 1, 2, 3. And then we know that we're going to do 2 times 1. 2 times 1 is equal to 2. 2 is a single digit. So if I'm teaching a child, I'll just say go back 1 column. But because we're adults, I would say, well, imagine it to be a leading 0 is a 2. So even when you write some files, this is how you make sure that the filing system knows that it's going to be in order. I always put 0, 2. Even when we do month 0, 2-digit month, so we have 05, 03, May 3rd, May 3, right? So that's why I would say 02. But if it was talking to a child, I'd say go back 1 column. That's it. And then I'd be 4 times 2 is equal to 8. Again, it's a single digit. Go back 1 column and add the 8. So my final answer is 28. So how fast are you going? You're going 28 miles per hour.
Question.
Yes.
That because we determined that this was going to be a 3-digit problem,
Yes.
the 02, the 02 really represents 0 in the hundreds place and 2 in the tens place.
Correct.
And then when you go 2 times 4,
8. Yes. Same
then
thing.
that's really the tens place that you're, and so it'd be 0 in the tens place and 8 in the ones place.
Correct.
Because
Correct.
yeah, because the 1 represents the hundreds, the 4. Anyway, so when we say 02, we're really saying 0 in the
Hundreds.
place and 2 in the. So when you say, so if you're teaching that to kids, you just say 02. But wouldn't it be good to just say what the 0 actually represents in the hundreds place? Or
You could.
is that too confusing?
I think it's too confusing.
Okay.
I think it's too confusing. You could try it.
It just helps me to remember, because if you were to do that, let's just do it mainstream, just regular math, how we were taught when we were younger, we would put 14 times 2.
Yeah. So it'd be 14 times 2.
We
We
go
would
2
do,
times 4 is 8.
yep. And
And
then we
2
have to bring this down, and then we do 2 times 1.
Oh, that's not how I just put 28. I would just 2 times 4 is 8, and then 2 times 1 is 2, and I would put the 2 there. I wouldn't even put the 20 there.
Right. Right. But but that's because we know. We know that it's 10 times 2. But the kids, if they're young, we always have to bring it down. When it becomes more digits, you have to bring it down. So even if we had 3, 7, 4, 8 times that by 2, we would do 16. We bring it down. We do 8, bring it down. We got to go here, 7. So that's 14. Bring it down again. 1, 2, 3, 1, 2, 3. And then we have 6. Then you add it all together. 6, 9, 4, 7.
So those zeros represent placement value when you're doing that multiplication, just like when you do your 02 in the problem, that just represents placement value.
Yes,
What
0
that
is
zero is, it's a placeholder.
Yes. The 0 is a placeholder, but because we go from left to right, anytime the digit is single digit, it would always go into double digit. So you can test it out with your files. I know, like, when you increment files, right, on your computer, the computer sees 0, 1, 0, 2, 0, 3. Even if you did it in Excel, you do 0, 1, 0, 2, then it will become an order. And then when you get to 0, 9, and then there's 10, see how it increments? This is zeros. And then you start again. 1, 1, 2, 3. But we in just regular, we ignore the 0, but computers, and when we write, we should not ignore the 0.
It's just easier for me now that we figured out how many digits this problem is going to have. You have it's 3 digits. You know it's going to be in that there's going to be a hundreds place, there's going to be a tens place, and there's going to be a ones place. And
Yes.
so that's why I,
Yes.
that's what's
So
helping me to keep track what place, because I don't know why we automatically do that. We just automatically know to go over when we're doing the regular math, without the abacus. Why do we put a 0 when we go to the 8? Because see, 2 times 4, that's going into the tens place. So then
yes,
we put 80, and then
yes.
2 times 7 is really 140.
No, it's actually 1,400
Sorry,
because there's,
sorry.
yeah.
Oh, because it's 7. Because the
Yep.
7. Because that's 700. Okay.
Yes.
So yeah,
Yeah.
14. Yeah, I don't
Yeah.
even think about the 100, but yeah, that's
Yeah.
exactly right.
So when in mainstream, they call it new math because they want the kids to understand place values. So they actually do this 40 times 2, and then they do 700 times 2, and then they do 3,000 times 2. This is not new math. This is just Common Core. But because we're writing it out, it looks overwhelming.
Okay. So the reason why they're teach is so that they recognize placement value. But aren't
Yes.
you recognizing placement value? So, okay, so because they have 2 times 8 is 16, but you're carrying the 1. I see what you did. You put the 1 down there instead of up above.
Oh, right. Right.
Okay.
Yes, I
And
think that yeah. So yeah, so if it's 3,748 times that by 2, so we know this is 16, carry the 1. We know what 8 times
2 times 4 is 8, plus
but
1
then plus the 1 is 9, and
9.
then
And then you go on to 2 times 7 is 4,
is
carry the
4,
1.
carry the 1. Oh yeah, I forgot about that.
Yeah.
Is 7. Yeah.
Yeah. So I figure because you're only multiplying by a single digit, you wouldn't have to do all that. But when you did that, you saw how the numbers moved over.
Yes.
Huh. Okay, so then how do you do the 3748 on the abacus?
Oh, same thing. 1, 2, 3, 4, 5. 1,
Okay.
2, 3, 4, 5. 3 times 2, 6. 0, 6. 2 times 7, 1, 4. 2 times 4 is 8, 0, 8.
Oh.
2 times
Oh,
8 is 16.
So you did the 2 times 4 is 8. So I just bring the 8 in the tens place.
Yeah, because it's a
Okay.
0, 8.
Yep.
And then 2 times 8 is 16. 1, 6.
6. So your answer is 7,496.
Yes.
Oh. But I didn't have to worry. Well, okay. All right.
Yes, you didn't have to worry about timesing it and then adding it because those are two separate.
No,
those
yeah,
are separate.
you're right. I didn't have to worry about
The one
now how come I didn't have to worry about that?
because it's part of the because it's the part it's when you 6, right?
Huh?
Plus 7 is plus the 1 plus 4. It's simple. Plus the 1 plus the 4,
Aha. Aha. Yes, that makes sense.
right?
Okay.
And then we do 8. 4 times is 8. 8 0 8 8 0 8. Add the 8. And then 16, add the 1, right? It's there. We just add the 1.
Oh,
Add
there's the one.
Yep. And then add the 6.
Okay. Wow.
But again, that's the difference between the but then what happens if it's let's do it again. What happens if it's 3 what happens if it's 3 digits? What is it? 3 7 4 8 45. Right? You can't do it now. You got to break it out.
Oh, let's try it. Okay. 5
Wait.
times 8 is 40. So you have 0, and then you
And then
carry
you
the 4.
right?
And then 5 times 4 is 20 plus 4. So you put the 4, carry the 2. 5 times 7 is 35 plus 2 is 37. Carry
Yep.
the 3. And then 5 times 3 is 15 plus the 3 is 18. Okay.
Then what do you do?
Okay, so 4 times 8. So then you have to go over into the tens place. So 4 times 8 is 32. So 2, carry the 3.
So I got to cross this out, carry the 3.
Wait,
4 times.
didn't I do that? Didn't I go over? Okay, because.
No, because this one was from before, right? This 4 was from the 5.
Yeah, because 4 times 8 is 32. So you have 2, then you carry the 3. And then
Yeah,
4
so
times 4 is
4
6.
is 16.
Plus the 3 is 19. So you have the 9, carry the 1, cross out the 2. Yeah.
Yeah.
And 4 times 7 is 28. Plus 1 is 9, carry the 2.
Wait, 28 plus 9 plus 9, carry the 2. And then
4 times 3 is 12. Plus 2 is 14. Now
right.
you have to add those all. So then you go 0.
Yeah, 0 6.
6, carry the 1. Oh, that's supposed to be okay. Wait a minute. Did we do something wrong? So
No.
4 and 2 is 6. 7 and 9 is 6. Carry the 1. 1 and 8. 9 and 9 is 8. Carry the 1. Yeah, 6. And then 1. Yeah. So 16,806.
Yeah.
Okay.
Okay. So in Abacus, 1 2 3 4 5 6. This is where you would have to switch to this.
Oh yeah.
Because you don't have enough.
I don't have enough room.
Right. 1 2 3 4 5. We need 6. 1 2 3 4 5 6. That's why you switch to this.
I see. Can I just go over to the one that doesn't have the dot? Or will I still need to move over?
What do you mean?
Okay, on the small abacus, can I go all the way to the right?
Oh, yeah, you could if you wanted to. You just have to ignore this dot. You could do it. 1 2 3 4 5 6.
Now I ignore that dot because I don't know where my abacus is.
Okay, so we'll do that. So then we do 4 times.
I'm gonna write the problem out myself so that I can, because I'll be like 303
7 4 8
times
that
45.
Yep.
Okay, so it's 1 2 3 4 5 6. So it's 6. It's just a 6 digit.
Yeah. So it'll be 6 digits.
Okay.
So
And
we're going to
then-
do so this is what we call distributive property. Kind of like what we did here, right? But okay, so 4 times 3 is 12.
So I go way over to the sixth digit place.
Yes. You start from the left.
Okay.
You
Okay.
could start from the right, but
I
I
don't
always
want.
start from the 4 times 2. I'm sorry.
Let me get
4
the
times
12.
7.
Let me get the 12. So 1 and then 2.
Mm-hmm.
Okay. And then 4 times 7 is 28. So then I go the 2 and then I
And
do
then
8.
uh-huh. 4
Okay.
times 4.
4 times 4 is 16.
Mm-hmm.
Oh boy, that's
Add
when
the 1. Add the 6. Nope, you keep going. 4 times 8 is 32. Add the 3. Add the 2. We're done with the 4. We have to recount. 1, 2, 3, 4, 5. Recount. 1, 2, 3, 4, 5.
oh, you're starting from, okay, 1, 2, 3, 4, 5.
This is my
Oh,
running total. So what did we do? We did what? Did we do something wrong here? Is it 18 or did I say something wrong? What number did you get? 1,
I
4,
got
9,
1499
2.
2. That's what I got.
You know why? Because we did the 5 first. We're doing the 4 first. That's why.
Okay.
So that's why it's different. So here it is. 149920.
Oh, cool.
That's why.
There's the number. Oh,
Yeah.
wow. Oh, wow. Oh, you actually see that. And then we're going to be getting the 18740 when we do the
Yes.
5.
Yes.
Oh,
Yes. But because we do it all together, it's not as, I don't know.
oh, yes. And it does say the 0 in that part because oh, and I actually see the 0 too. Okay. Oh my goodness. I'm sorry. I never saw that because you did it, just how we've been taught, and you
Yes.
actually see the numbers, except you're seeing the bottom number first because you multiplied by 4 first.
Yes.
And then oh, okay. Sorry. I'm just, okay. Okay. Oh, good. Wow.
No,
Okay.
you're absolutely good. I love it when you I love it when you make the connections.
Yeah. I get the connection now.
Yeah.
Wow. Because we're just so used to just doing it. But because I can see it on the abacus and I see it written out there,
Yes.
oh, wow. Okay.
Yes. Right? It's such a small difference to be able to see your numbers. It's so
Yeah,
crazy. It's so
on
crazy.
the abacus. That's cool. Okay. So let's do that other one. And then you counted you start over again and you start at the 5 and you count 1, 2,
2,
3,
3,
4.
4, 5. So
Now,
I'm
why
here
do you skip the 4? Oh, because you're
because
in the ones place.
we're done. Yeah. Because
Done.
we're done with the 4. We don't need to recount it.
But on the abacus, you're going 1, 2, 3, 4, 5.
Yeah, I'm not doing 6.
Oh, yeah. Okay, so you're starting. Okay.
So I just take 1 down. So I start from 6, I just take 1 down and then I'm at 5. And then if I had more numbers, right? If I had 3, 4, I'd do the same thing. I would take 1 number and then 1 number and then 1 number. It all depends on how many numbers I have here. But
Oh,
that's the
that
system.
also helps you keep track too.
Yeah. Yeah. It helps you keep track what the numbers are.
Okay.
Because this will get unruly. If you have 4 digits times 4 digits, that gets really unruly.
Okay. Okay. All
Okay.
right.
So 5 times 3 is 15.
15.
Add the 1.
I can't add the 1.
So you do. Plus the 5 minus the 4. That's
Yeah,
adding the
yeah.
1.
Plus the 5 minus the 4 is
And
adding
then add the 5.
uh add the 5 is plus the 10 minus the 5.
Yep. And then we're here. Stay where you are. You took away the 5, stay there. Don't move it. So then my next number is 5 times 7 is 35.
35. So
So
that
you add,
add the 5 minus the
no. Add the 3. Add the 3 first. 35.
oh, I can't
35.
okay, do it again. 35.
Wait, add 35. So you're adding 35. You said you add the 5, take away the 2.
Yeah,
Yeah.
that's right.
Oh, okay. So then here, add the 5. Can't do it.
Can't do it.
So what do you do?
It's okay. Plus the 5. You do?
Yes.
Oh,
What?
add the 10
Yes.
minus the 5.
Yes. And then 5 times, 5 times 4
5 times 4
is
20.
20. What do you do? Plus the 5 minus the 3.
Oh, okay. Minus the 3.
2, 0. Remember our placeholder, 0,
Yeah.
right? And then what's our final one? 5 times 8 is 40.
Okay, 40 is plus the 5 minus the 1.
Plus the 5 minus the 1. Yep. I know I messed up somewhere because I moved some beads. I think it was supposed to be like this.
Let me see if we got
I'm
1,
sorry.
6.
Oh, yeah. 8.
Let me get to 8.
Yep.
I did
Yeah.
not.
It,
Let me get the 8. I got the other 2. I got the 6 and 6, but I did not get the 8. I don't know where I messed up.
oh, because my fingers, yeah, it might be because my fingers were moving.
Okay.
So let's do it again. Like we have our running total. So we do 1, 4, 9, 9, 2.
Okay, 1, 4,
9, 9, 2.
2.
Okay, so we start from here. Add the 1 plus the 5 minus the 4. Add the 5 plus the 10 minus the 5. We stay here.
Okay.
Then we do plus 3 plus the 5 minus the 2. And then plus the 5. Plus the 5 is plus the 10 minus the 5.
Yeah.
And then what do we do?
You're
20
20.
plus the 5 minus the
3.
3.
3.
Yep. And then we do it again. 40 plus the 5.
5 minus the 1.
Yep.
Oh, wow.
That's what it is. Yeah, I think it's because I was moving my abacus too much that I messed up the answer.
Okay.
But yeah, that's the answer. So it's 1, 6, 8, 6, 6, 0.
Oh. Okay. Yeah, I okay. Yeah,
Did you get it?
I did. I did, but then the first time I didn't think we were doing that many formulas at all when we were doing the 18740. And then we had a couple of formulas in there. So then that's when I started to.
Well, I think we were also talking over each other, and I wasn't sure where we're going. So I think that's also what messed us up as well.
I see.
Yeah.
Wow.
Yeah, because I got confused when you say minus the 5. I thought you were talking about this 5 as opposed to this 5.
I was
That's
talking about in the tens place.
Yeah, yeah. Yeah, that's where I messed up, and I was like, oh, so
Mm-hmm.
yeah.
Wow.
But yeah, so because you could see it, right? But
yeah, that's the first time that I saw the 1499920. I did not see the 18740 though. I don't know.
no, because you're adding it, you're doing a running total. So when you add it, you saw the 5.
Oh, you'll see the 168660 because
Yes.
so how
Yeah.
come I don't see the 18740?
Because you don't see it, because we're adding it as we go. So we have 4992. We add the 1. You don't see it here. We add the 1. See, we added the 1.
Yeah, you added the 1. Yep. Okay.
right?
And then go to the next one, the 9.
And then we add the 5 plus minus the 5 plus the 10. So we had to carry the 1. That's what we did here, right? We carried the 1 over here to make it 6.
Oh, wow.
But
Oh,
then this is still 6.
uh-huh.
Oh, wait, where are we? Oh, yeah, this is now 4. This changes to 4. Then we have to add the 8 to this. Add the 8 to the 4. Add the 9. I'm sorry, wait, what are we doing? We're adding the 9. No, we're adding the 8 to the 4. That's what we're doing. So we add the 8. It's what? Is that right?
No, I think yeah,
I'm miss.
you missed.
I'm
I got the
yeah.
1, how we added the 1 and the 4, but
Oh,
then
and then the
lost
5. So that's the 5. Oh wait. So we had to take away the 5 from here. Deconstructing. Okay. So
you.
we did. So we're down to, we took away. So then we have 4.
There's your 9. Yep, because the
Yeah. So we broke it out. So this is my 5 and so I minus the 5 and I have my 4. Then what do we have to do? We have to add the 8. We didn't have an 8. Where do we get the 8 from? Oh, no, where we get? Oh, we got the 8 because we had to plus the 3 somewhere.
uh-huh.
But we're not adding 8. What are we doing? We're adding 5. We did 3. We adding 35.
Oh, wow.
Yeah. So that's why we don't see it.
That's why
Because
you okay. Oh, wow, that's a lot harder than I realized.
yeah, because we're not at okay. So let's break it down, right? So what did we do? So if we really broke it down, we did 40, 200. What's after that? 3,500. And then this is where we get it. This is where we get it. That's why you break it out. So you could see this broken out. So we did the 15. Now we have to take away 35. Because we already took away the 5 from the 8.
Oh.
Yeah.
So is this why they're having them do the multiplication out?
Yes. So they could see this number 740. So you could see this number broken out. But
Oh, yeah.
oof, it makes it complicated.
I see. Okay.
So then what are we doing? Okay, so we did 15 here, and then we got to do 30. Are we doing 30 here? No, we're doing 30 here, right? 30, add the 5, add the 3, add the 5.
So that's plus the 5 minus the 3.
Plus the 5 minus the 2,
2, yeah.
and then plus the 5. This is why we don't see the result.
Oh, why is that?
Because we're breaking it up. Because we're doing the times table.
Oh.
That's why. That's
So
why we don't.
that's why in Abacus you don't see that.
Yeah, that's why Abacus you don't see we don't see this number as a whole.
I see.
Which I wonder how mainstream does it. I wonder if they say, okay, you have this number, now subtract it. Maybe that's what they do, or add it. I don't know.
They have it, and they make sure that the placement value is because they're starting from the ones. And
yeah.
So my question is, can you multiply and start from the ones and then do the tens? Start with 5 instead. What will you get?
You can. It's the same thing. Yeah.
It is?
Yeah.
Okay.
We can do it. So, but my question is, what happens when they need to do double digits? That's my question. Because if they break it out this way, that's only the 5. What do they do with the 4? do they have to do another set? Right? So another set is 3,000, right? Times that by 40 gives you 1, 2, 3, 4. 1, 2, 3, 4. And then 700 times that by 40 gives you 28. And then 40 times 40 equals 1600. And then 8 times 40 equals,
320.
thank you, 320. And then you have to 149920. Then you got to combine it. I don't know what they do if it's double digits like this, is my question.
I haven't seen it, I haven't watched them yet, so I wouldn't know. I'm
Yeah.
just used to doing it this
way.
this way.
Yeah.
You have to make sure that when you do the four times 8, you put it under the tens place, then keep on going.
Mm-hmm. Mm-hmm.
So even though you're multiplying in the ones place, you have to line it up in the tens place.
Right. Yeah. So if we go the other way, let me rewrite it. So we have 3, 7, 4, 8, 45. It's the same way. So are we doing it? You said abacus way. So we do 3, 7, 4, 8 times that by 45. So if it's here, you still have to start at the 5 because you're not going to count this.
Right.
You cannot count the 4. I think that's why we do it. I think that's why we do it the other way.
Oh, so that's why you go in the 5s, because then you'll be going in order.
Yeah.
At the farthest.
Yeah. We go in order. Yeah. You could do, I don't even know. We could do this. We could do 5 times 8 is equal to 40. So 4 and then a 0. But that means I leave it to 0, but then I have to go back 1. And then I got to do 5 times 4 is equal to 20. Add the 2, add the 0, add the 2, add the 0. And then I go back here because I have to start from here. Then 5 times 7 is 35. Add the 5, add the 3, add the 5, add the 3. I guess I could do it that way. You would always have to start from 0 to, yeah. So then 5 times 8 is 40. Add the 0, add the 4. Am I right? Am I wrong? I'm wrong. Oh, I'm sorry. 3. 15. Sorry. Let's go back. Add the 40. 0 and the 4. 0 and the 2.
You're starting over?
Yeah, I got to start over because I did it wrong here. It wasn't supposed to be 8. It was supposed to be 5 times 3 is equal to 15. That's why. So 0, 4, 0, 2, 5, 3, 5, 1.
Okay.
So it is 1, 8, 7, 4, 0. And then we do it, then we have to do 6. Oh no, so if I start from here, I don't even know.
I think it's easier that way. Yeah. I think it's easier the other way.
Yeah, because then here, you have to account for the 0. So I guess you start here. So it'd be 4 times 8 is 32. Add the 2, add the 3, add the 2.
That's the 5 minus 3.
Thank you. Add the 3, add the 3, plus the 10 minus the 7. So then 4 times 4 is 16. Add the 6, add the 1, add the 1, plus the 10 minus the 9. 4 times 7, 28. Yeah, 28. Add the 8, add the 2. 4 times 3. 4 times 3 is 12. Add the 2. Add the 1. The answer's still the same, but it does take a little bit of thinking to go the other way.
No, I like the other way.
So I think, having said that, I think when we start at the 0, at the 4, you have to start at the tens place.
Yeah.
Yeah, that makes sense.
Mhm. Yeah.
Yeah. But I was listening to this one audiobook, and they were saying that going from left to right is actually more natural than going from right to left. And I'm not sure why mainstream math does left to right. I don't get it.
I mean, they go right to left.
Sorry, yes, right to left. But we read from left to right. We say 18,740. We don't say 4, 40, 700, 8,000, 10,000.
Oh, that's why you're saying multiplying makes more sense to go from the left to the right and how you're reading the problem.
Yeah, exactly.
Okay. Okay.
So, okay. So, good. So that was a little bit of a digression, a detour of the 14 times 2.
Yeah.
All right. So we have the bananas. Do we understand about the bananas?
I think
So it's the triple. The triple just means times 3, not times 2. All right. And triple means times 3, not 3 times 3, not to the power of 3.
Okay, correct.
Right. So it's not, it's not 3 cubed. That's not what it is. It's supposed to be 3 times 3, because 3 is what triple means.
Mhm.
That is a math fact that we need to know. And then the same thing with the math fact is here. 9 times 3 is 27.
So to do that on the abacus, because you were doing those, so so we would be doing, well, let's do your three times table.
Right. So if the child doesn't know their 3 times table, then I would start talking about cumulative addition. So we need to know 3 times 1 is equal to 3. 3 times 1 is 3 plus 3.
Oh, so you say it 3 times 1, and then you go plus 3 in the, okay, all right.
Yeah, I think so. And then 3 times 2, add another 3. How do you add a 3 here? Plus the 5 minus 2. Plus the 5 minus 2. So my answer is 6.
Oh, and then plus the 5 minus 2 is going to be here and out. No, not all the time.
No, not all the time.
Because you can add the 3 there. The 3 times 3, because there's 6. So
1, 2, 3. Yep.
3 times
So then it'd be
3
9.
is 9. Okay. Now,
So here, 3 times 4 means that I'm going to add another 3. How do you add another 3? Plus the 10 minus the
7.
plus the 10 minus the 7. My answer is 12.
Wow.
Oh, sorry, 4. So then 5. So 3 times 5. Can I do it? Can I add 3 here? No. I have to plus the 5 minus 2. Plus the 5 minus 2.
Oh, and
So
then
my answer is 15.
15.
Yeah. This is why after knowing how to make a 10, you can introduce addition, cumulative addition. 3 times 6. There's my 6. Can I add 3? Yes. 1, 2, 3. So my answer is 18.
30. Oh, no, 18. Yeah, 18. Sorry, yeah, 18.
3 times 7. There's my 7.
7 is 4. Oh, plus the 3. Okay, so I cannot add a 3, so I have to do plus the 10 minus the 7, right?
Yep. Plus the 10 minus the 7. So my answer is 21.
Oh, 21.
3 times 8.
3.
8.
3 times 8.
Add the 3. Yes, 24.
24.
3 times 9. Put the 9 here. Can I add 3? No. How do I do it? Plus the 5 minus 2. Plus the 5 minus 2.
That
So my
gives
answer is,
you 27.
yeah.
And you go as far as that.
And that's as far as I go. I don't need to go anything farther because then we do distributive property. And you can't go as far because there's only 9.
So the one in the far left column is just keeping tally of, because you're saying 3 times 1 is 3.
Yep.
3 times, so like I just got to remember 3 times 1. Okay, all right.
Yeah.
Okay, can I, so then you see that 3 times 9 is the answer to the problem. But we practiced doing our multiplication facts with.
Yes. Yes.
So my question is, wouldn't it be easier just to say 1 times 3, 2 times 3, 3 times 3? Because
You could.
your running
Yeah.
total is that part.
Yeah. Yeah. You can. It should be times. The great thing about times is that it is interchangeable. You could say 1 times 3, 2 times 3. That makes more sense too.
That way you know that you're adding the 3. You know when you're adding the 3. Because the other way, I got confused, and then I start saying, well, maybe I need to add a 9. So that's probably how I would do it, is like that.
Okay. Yeah, that makes sense too. But then you should also know how to do it this way too. Because the difference between the two is you have 3 boxes. If I do 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, or 6 circles, 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So those are the 2 different ways we can show what 18 is.
Usually, but on the abacus, it's still going to be the same.
Yeah, exactly.
So
exactly.
I would go with the one with the least resistance and just do it with the 3 boxes.
Yeah, for sure. For sure.
Okay. All right. So yeah. So if you're going to practice math, you go 1 times 3 is 3.
Yep.
And 2 times 3. Okay. I see I don't have enough beads. So times 3, I would have to go plus the 5 minus the 2.
Yep.
Then
and
2
then
times 3
put the answer here. Yep.
Oh, okay.
Yeah.
And then you go 3 times 3 is 9 because you can add it.
Uh-huh.
Oh, I can see that. Okay. And then 4 times 3 is plus the 10 minus the 7.
Yeah. And then write your answer.
12.
And then write your formula so you can solidify the fact family. Solidify your formulas.
Aha. Okay. So
But
I have basically done. Okay.
yeah, but because it's tedious, you're going to start memorizing as well. The reason why is because they were saying,
you start to see the pattern of using.
Yep. Well, 1, you see the pattern, but 2, they were saying that there is a connection between writing it out and your brain. That's why they're going to bring back cursive writing, they said.
What? They are? That's good. They should have never taken it away.
Yeah, there was studies to say that cursive writing actually helps the brain connection between what you're doing and what you're they say that there's a connection between that. I don't know if the schools are going to abide by it, but there are studies to show that handwriting and cursive writing helps the brain.
Well, maybe you had to take something away to realize that you really needed it in the first place.
Yeah, but I don't know if it's going to happen. You know what I mean? Like, I don't know how much people were going to resist because everybody's going to be like, well, we have computers, you just type it out. You know what I mean? So now we're going against, like, maybe it might be economical to go digital because you don't have to waste paper.
That's true, but you have history and you have old documents. And if you don't even know how to recognize what a cursive letter is and how to interpret, there's I mean, we're creating history now, but there's also history in the past.
That's true. That's very true. But it could
But
be one. It could be like a hieroglyphics. Like it will become a dead language really soon. Like cursive writing might be dead. I don't know what they're going to do with the science behind cursive writing. I don't know if they're going to
I
bring
see.
it back. That's
Okay,
what I'm saying.
that's right. Okay, it makes sense.
Yeah,
Yes.
but that's why I would write it out. That's why I would write it out as when the kids are young, write it out so then they can start memorizing and see the pattern and they solidify their math facts.
Okay. I like
And
that.
then they're going to get tired of writing. They're going to be like, okay, I already know how to do my math facts. Then you get them to just do this until they've memorized their multiplication fact. But it is really just practicing. It's really just practicing.
So when your sons did this, did they just realize that 6 times 3 is 18? Did when they did it on the abacus, did it help them memorize, or did you need to do flashcards?
No, no, no. It helped them memorize because they got tired of it. It pushed them to memorize.
Oh, okay.
Yeah,
So,
I didn't do flashcards with my kids. The only time I did flashcards was probably do vocabulary. But
okay.
when it came to math, I did everything on the abacus. So every time, so yeah. So the way I teach, I would rather have them go through the pain of adding it on the abacus.
Okay.
Because what do they say? That you learn from pain. going going to flashcards, there's really no strife. It's just passive understanding, right? Passive memorizing. Whereas this is like, oh man, I gotta move this again. I gotta, you know what I mean? So there's a little bit more strife when you do it on the abacus.
So did they take it pretty slow at first and then they got pretty quick with it?
Oh yeah, but don't forget, my kids knew their multiplication table when they were in kindergarten.
Oh, how did you teach them then?
Well, through the abacus way. So the curriculum that I had was a little bit faster than what you're going through because I didn't have all the activities. You have a lot of more activities, so I just wanted to make sure. And so my activities, I wanted to make sure that they understand it. Whereas when my kids were going through it, we just told them to memorize the formula. I didn't tell them why. I just said just memorize the formulas, memorize the formulas. So we did a lot of heavy lifting on the memorizing only the formulas. But I started going towards more like, okay, you got to start doing adding and adding to do your multiplication facts.
How old were they when you started the abacus with them?
The first two, I think I started them at 4, maybe 5.
But they didn't have all this fun stuff that you're providing for us.
No, no. This has just been the past 2 years. My boys have been out of abacus for about 5 years now. 4 years.
Do they remember it still?
Oh yeah. If you give them an abacus, they'll still remember it. But they now do it like they can't teach you, but they know how to do it. So if I gave them some questions, they'll know how to do it. And then sometimes with division, I have to jog my youngest one's memory because he doesn't have the greatest memory. but but when I jog his memory, he'll be like, "Oh yeah, oh yeah, oh yeah." So it depends on how. Like I was never really like, "You got to know it this way." I was never a tiger mom when it came to having them understand abacus. I just wanted them to be comfortable with numbers. I want them to be comfortable with understanding. Sometimes they get it wrong, sometimes they get it right. If they get it wrong, then you go back and you do it again. You keep doing it again until you know until your answer is correct and why you got it wrong.
Okay. So so you taught them young, but when they were in school, did they actually use the abacus themselves, or did they do mental abacus?
They did mental abacus to double check because the teacher would teach them one way, and I said, follow what the teacher says, but you can use the abacus to double check your answers. And that's what they would do. They would use the abacus in their brain to double check if they got it right. But their questions were super simple, right? It was like 83 times 2. They could do this in their head.
With the abacus?
Yeah. Because by the time they were, I don't know, 4th grade, 5th grade, they already been doing multiplication uh three times 3 digits, 4 digits times 5 digits or whatever. So by the time they got to grade 4, they were doing, I think, 5 digits times 4 digits. So that in itself, they just kept practicing.
Oh my gosh.
But so that's why if you go back to the 2 digits, it was easy for them. They're like, oh, this is so easy. Because you go a little bit harder, and then when you come back to mainstream, it was easy for them. Doing arithmetic in school was easy for the kids. Going into like geometry, they hated it because, well, my middle one hated it because it was a lot of memorizing what the angles were, what the names were. There's a lot of memorizing in geometry. And then when my oldest one went into algebra, he was like, I know this, but I don't know this because I was never formally taught. I'm like, it's because there's a little bit of abacus inside algebra, which is what we did here, right? This is known variables. The 4 is a variable. We isolated it and we substituted. This in itself is algebraic.
Mm-hmm.
So, but when I was going through and teaching them when they were young, and I didn't know, I don't remember algebra because it was such a long time ago. But then as my children started going through algebra, I'd be like, oh yeah, this is how algebra, and that's why I started going down the path of, I believe abacus is the gateway to complex math, because as they started going through algebra, I started seeing a lot more connections on how abacus is related to algebra.
Okay. Okay.
So all of this epiphany that I'm coming through right now is just recent,
I see. Okay.
because I didn't have a adult to talk about my findings, because they were all kids, and the kids don't know anything above what they are taught, right? And so the kids that would go through the learning center would carpet carp carp carm carpart compartmentalize.
Compartmentalize? Okay.
Yes, compartmentalize. I don't know why that's a hard word for me right now.
Compartmentalize, yeah.
Yeah. So they would say, oh, this is abacus class, this is math class. But I'm actually trying to merge the two. That's why I'm trying to bring them together. That's why this is great, because it was meant, so back, like even now, abacus world, it's either meant as an accommodation for those kids that are having problems, right? Mentally, special ed, whatever you want to call them. They get accommodation using or those people that are having problems with math, they're using the abacus to help them accommodate, or it's used in an enrichment program. There's nothing in between. And I'm like, how is that even possible? So my goal is to educate the quote unquote average ordinary people, which is us, and bringing it into how it will work to mainstream math.
Mm-hmm.
And that's my take. That's where I stand, because I believe that if we can use the abacus in mainstream math, we would be a lot stronger as a whole with our math, as opposed to being discombobulated with memorizing and being illiterate.
Mm-hmm.
Oh yeah, the truth about reading and becoming math illiterate. And that's what we're doing. And having it this way, it's still a bunch of symbols, and I can't comprehend all of these zeros because it's too much for my brain to understand. Maybe I'm a simpleton. Maybe it's too much for me.
Mm-hmm. Oh wow.
So
Okay.
I don't know. That's how I feel.
Yeah. Huh.
Yeah. Yeah. Okay. So if the 2,300-pound rhinoceros is charging towards you, you can block him with a wall. So we remember about the wall. How many 100-pound buckets of sand do you need? So if this is 2,300 pounds,
You have to divide it.
yeah. But how would I set it up?
How do you know you're dividing? What words indicate that you know you have to divide? Is it because it's asking how many 100-pound buckets?
Yes, because because the quantity is 100 pounds buckets. So we know that this is a container. So I need to know how many 100-pound buckets.
Okay.
So what
So
did they call it?
that's how you
Yeah.
draw that.
Yeah. So if I'm trying to build a wall, so X is equal to, is that right? No,
Hmm.
no, it'd be X times 100. Yeah, because I need to times this number with that's what it is.
Well, X times that 100 would get you the 2,300 pounds.
Yes, that's what I would do. So I would
So
have to set it up like that.
X is finding out how many buckets,
Yep.
right?
That's why you do division, because you have to minus the 100 here and you minus the 100 here.
Oh, how did you figure that? Okay.
Oh, because I have to isolate this X. This is algebra.
Huh?
But see, that's what I'm saying. Like, we don't know that this is algebra, but this is algebra because we need to figure out how many times are we going to add a 100 bucket? One time? No, because it's only 1 times 100 is equal to 100. 2 times? It's equal to 200. 2 buckets is only 200 pounds. Right? If I do 3 buckets, that's only 300 pounds. So we know that this is times. So if I need to times it, I need to cancel it out.
You need to do the opposite, which is
Yep.
divide.
Which is divide. That's why we know it's dividing.
Okay.
But how I would figure it out is exactly what I'm saying. Is like I would make it into small numbers. I'd make it into manageable chunks. And I'm like, oh, if I work it out this way, then I have to figure out my X times, sorry, I should do Y maybe. No, you know what? X period. And then this equals 23. Because I know what my answer is. I know how many buckets, but I don't know how many. I know how heavy they
Oh,
are.
how heavy it is, but you don't know how many buckets there are.
Right, exactly. So then I know to cancel it out, right? To cancel it, I have to divide it, or I divide it. I don't know, divide, right? And then divide. So that I
Okay.
know I'm going to 0, 0, 0, 0. So X is equal to 23 buckets.
So you didn't even do that on the abacus. I mean, honestly, I probably wouldn't have used the abacus. I probably would have done that.
Yeah, exactly, exactly. The only reason why I would use the abacus is if I can't see it or if I'm trying to teach a concept. But if it's you and I would do this just because we know how to do it. But if I was teaching the concept, I'd be like, okay, put it on your abacus, 100 divided by 23,000. How do you get that? 1, 2, 3, 4. 4 divided by 1, 2, I'm sorry, 4 take away 3 is 1. So we know our quotient is going to be at the ones place. I'm going to use this one over here because I have no more room, right? If I did this, I have no more room. I'm going to put my dividend on the abacus, 2300. And then I would divide it out. 2 times what is equal, I'm sorry, 1 times what is equal to 2 or less. If I can do this, then I have to skip one column,
And go to the left.
go to the left. Yes, because now I have to account for the digit. I haven't quite figured out, I haven't worked out this part yet, but I know that if I can do it, I need to skip this column and I need to go over here. So 1 times 2 is equal to 2. Add the 2 as my quotient. Now I have to subtract. Instead of subtracting here on the paper, I just subtract it here on my abacus.
So then you subtract the 2.
Yep, that's it. And start over again.
What do you have? 300.
Well, yeah, so I start over again. So I'm here. So 1 times what is equal to 3 or less? Can you do it? I can do it. So that means I have to skip this column, go over here. So 1 times 3 is equal to 3. Add the 3, that's my quotient. What do I have to do with this 3? I have to take it away. So you just take it away. So my final answer is 23. I know it's 23 because this is my ones. This is my tens, my ones and my tens.
Actually, I was able to follow you that time.
Yeah, see, because the concept, it's all about understanding the concept. Once you understand the concept, then you can change the numbers. But it's all about making sure that the numbers is manageable so you can understand the concept.
Yeah.
That's why I would still do it on the abacus to show the children what the concept.
That was a pretty easy problem though, because the zeros, 0 divided by zeros. I mean, you can't do that. So yeah. That was
Yeah, but we know as adults to cancel out the zeros.
okay, but when you're teaching a child, can you tell them to cancel out the zeros too?
I don't know. I don't know. I don't know how far do we need to understand the
Because
symbols
the
of
quotient, the quotient, no, is the quotient at the top? The quotient right there.
Yes.
When you put that on there, all you have to do is go 23 times 100. And then you get 2,300.
Yeah, but I don't know.
Okay, yeah,
but you know what? In mainstream, you have to account for the whole number. It's 100 divided by 200. That's why you get 2 here.
Okay. Well, aren't you doing the same? Aren't you doing the same when you're doing on the abacus though? In actuality?
No, we're not accounting the zeros. No.
Oh.
We only account for the 1 digit.
The 1 digit. Okay. And
we only go 1 digit at a time.
Okay. So if you did 10 divided by 2,300, you'd be doing the same thing.
Well, yeah, exactly. But if it's 10 divided by 2,300, we count 1, 2, 3, 4, take away 1, 2, 2. So my starting point would be 2, not 1.
Okay.
So my starting point is now different.
Okay.
But I'd have to get a bigger abacus.
Okay, I see.
Right? Because if I did 2, it would actually be 320, it'd be 230. Yeah. There's not enough room to do this.
On the abacus. Okay, I see.
Yeah.
Okay. All right. Yeah. So, wow.
Well, I guess you could do it here, 1, 2, and then you just know you're going to do 23. Yeah, right. But you have to remember that there's a 0 and a 0. You could do that. Right. So it'd still be 2 here, 3 here. It's still 230.
Push up the abacus so I can see it.
Oh, sorry. So 1, 2, right? I put my dividend here. You're going to have to just remember that there's an extra 0, but zeros really don't, it doesn't matter. So that's why if we did 2 times 1 is 2, you can do it. You skip this one and you go here. So that's 2. Take away the 2. And then you do it again. If I can take it away, then if I can multiply it out, then I can go here. I have to skip. So I have my 3. So then I know it's still going to be 230. I mean, you could do it. You just have to ignore the zeros.
I see. Oh, okay.
But yeah, going back, the questions are simple, but it's the concept that I'm trying to teach.
Right. Okay.
Yeah. So I would still do it on the abacus for the kids.
For the kids. Okay.
Okay. So we talked about this one. If the tree's branches, right, could each be cut and sanded into 4 boards. So one branch is equal to 4 boards. That's how I see it.
Mm-hmm.
How many boards would George have scored to make a cool canoe? So because I know that this is one branch equals to 1 board. So then I can do what? How many boards to the branch? So if I did 4 boards, this is where units come into place, right? For 1 branch equals 20 branches.
I should multiply.
Yeah, you have to cancel this out, right? This is my x. You have to cancel it out. You have to times it by 20, times this by 20.
So we got to solve for x.
We got to solve for x. We have to isolate this variable. So this crosses out, that crosses out. And then we have 20 times that by 4 equals 80 is equal x. Because branches cancel out. So let me rewrite that. So 4 branches for 4 boards
For
for
one
one branch, right? They have to equal to each other. 20 branches
equal
is
x.
how many boards? If you notice, this is also fractions,
Mm-hmm.
right? So then what happens? We have to cancel it out. So this is the 20 branches, right? 20 branches. There's my units. We have to times it. So the branches cancel out. We're left with 4 times 20 boards. This gets canceled, this gets canceled, right?
So then you go on your abacus.
Oh yeah. So then I could do 20 times 4. 1, 2, 3. 1, 2, 3. 4 times 2 is 8. 8 is a single digit. 0, 8. My final answer is, and then 4 times 0 is 0.
80. Yeah.
0, yeah.
Yeah. Okay.
Right.
Yep.
So, but I think the biggest thing is setting it up.
And showing your work.
Yeah, showing your work. The way I tell my kids is what you're doing is you're teaching the teacher how to do the problem.
I like that.
They're not understanding to show the work. So I say, well, you need to teach them. How do you teach them? And I think that's the problem, is that a lot of kids don't understand how to teach.
Oh, I like how you have to. So by showing your work, you're teaching the teacher, or
Yes.
you're basically showing the teacher that you understand the problem.
Yeah, but
I
yeah,
like the other way. You're teaching the teacher.
yeah, you're teaching the teacher, or you're teaching mommy, or you teach daddy. You know what I mean? Like the kids love to teach, but they don't know what they're teaching and why they're doing it. So instead of saying show your work, maybe they should say teach me how you did it.
I like that. Teach me how you did it. I like that. I'm gonna write that down. Teach me how you.
Yeah, And I think that's some of the things, like it's just the nuance of just giving them the responsibility, but giving them the confidence to be able to teach somebody else, because they teach all the time. Let me show you how I jump, you know what I mean? Or watch me, this is how I do it. They want to show us, but we don't give them the vocabulary, I guess, to
Yeah,
understand that what we want is you to teach me how you count. Let me tell you how I count.
I love it. Okay. Wow.
Okay, so the small little nuances that I pick up.
No, they're wonderful. They're
If you put toothpicks in an ice cube filled with mango papaya punch, you can make mini popsicles. If you make 43 popsicles, popsicles, and you give away sets of 10, how many extras are left? So if I give one set, that's only 10.
Mhm.
If I give away another set,
That's only
this
20.
is only 20. So I know I have to do division,
Yep.
right? Because we're breaking it up. And I think this is a very huge concept. I don't know if they would understand that.
Mhm.
You know what I mean?
Mhm.
So then what do I
Well,
do?
sets of 10 is a group, and you're taking
Yeah.
that group to find out, well, yeah, sets of 10 is a group.
But then I guess the question is like, how would it be taught in school? Do they write it out? Okay, if I have sets of 3, I have 30. If I have sets of 40, 4 sets of 10, that is equal to 40. Right? Is that how they teach them? Or do they teach them, well, you have to divide? I guess the question is like, how do you tell the kids to break this up into groups of 10?
I think just the way you just did it right there.
Oh, okay. Okay. So then I know, then what do I have? I know I have 4,
But
but
then you,
that's
but then
I have
you can't make another set of 10 because you only have 3 as your remainder.
yeah. So then I would have to minus. So I have to do 30 uh 40 43 minus 40. So that gives me 3.
So
So I have
the first step is to divide to find how many groups of 10 you have, and then
yes,
you take 43 and you subtract
your sets of 10.
sets of 10 that equal to, okay.
Yes. How did I that's how I see it, because you give them away in sets of 10. So because it's a set of 10, I need to figure out how many sets I give away.
There we go. Yes.
That's why I think that's why this is more complicated. What grade is this for?
I don't know. It was just a story, but I have no idea I mean, they have in the book, whenever they're doing a problem, they'll give
Yeah.
you a problem and they'll say this. Hold on, get to it. They'll have wee ones, little kids, and big kids. And then
Oh, yeah.
they have a problem. So they're not, saying what grade level it is. And maybe the
Right.
grade level, I mean, because they have the problem appropriate for the wee ones it's obviously gonna be for someone maybe, I don't know, maybe 5 to 7 or something, or 3 to 4. I
Yeah.
mean, you're like, you ever, and of course I didn't, and they built upon that problem. When I gave it, I kind of gave either the little kids or the big kids, but they took that same problem and they made it simple, and then they added upon it and made it a little bit harder, and then they
Okay.
added upon it again. And if I knew where I put the book, I'd be able to go exactly to the problem. and I don't know where I put it. But
That's very interesting.
that's how they built it. I just gave you kind of like the hardest one because I knew the easier ones we would be able to really solve really quick. But maybe next time when I do that, I will do a problem, and plus they have a story. They have a background to the story. I just went straight to um the questions.
I think it's fine that I get the questions. I was just questioning their methodology because I don't have the book. You know what I mean?
Right.
Because
Yeah.
like I wouldn't, I don't think, maybe I would introduce this later after they do division.
Yeah.
You know what I mean? So I could introduce this like later on when I start introducing division, and I could see that. But I wouldn't do that right now because they're only doing adding and subtracting.
Well, like they have this problem. It's like the 10-second rule, okay? And so for wee ones, they say if you drop 8 corn puffs on the floor and your dog snarfs up 6 of them, how many are left for you? So you
Okay.
know that this is going to be a subtraction, right? 8
Yeah.
minus 6, and since we know how to go 8 8 minus 6 is easy because you just subtract the 6
Yeah. Right.
and you get 2.
But yeah.
And
But
then the
that's
next,
because you could see it.
yeah, and then the next, so then the little kids, they go, if you drop crackers on the floor and you think they become illegal after 12 seconds and 8 seconds have passed, how many seconds do you have left to rescue those crackers?
Oh my God.
Yep.
Really?
So, yes.
Wow.
And then so that's for the little kids. So you would have to subtract. You have 4 seconds. And then the next one, it says for the big kids, it says if you spill 120 Cheerios on the floor, about one bowl full, but half are wet, how many will eventually shrivel up and stick to the floor if you leave them there?
Okay. That's really creative.
Uh-huh. So
But
half
it's
means you have to divide, I guess. So
yes. Yes. Half
yeah,
is dividing.
yeah, when it says half. So that's how they build up on the problems.
half half you need to know that's 1/2. But see, that's the other thing. Like they have those, I don't know. Yeah, as long as
Is this a pretty complicated story problem?
it is pretty complicated because you have to process the idea of what half is, and then you have to process the idea of what it means by it all shrivels up. You know what I mean? Like the actual concept of, yeah, that's
I wonder if we're reading too much into that. Maybe they're making it fun. And maybe that's the part that we're making the main
yeah,
the key
yeah,
half.
yeah. The key word is half. Yeah, but I think they're also introducing like vocabulary as well, and I think I think that's another problem because sometimes the kids don't know. Like my kid is not a strong reader until recent. Like now he's a strong reader only because every day I'm telling him we got to read, let's read. So I'm taking the time to read with him every day for one chapter. So now he is a stronger reader, but I wonder with the amount of vocabulary that they're using, are they also trying to introduce vocabulary? You know what I mean? With the problems.
Yeah, and then that's when I would just do some word inquiry,
Oh yeah.
etymology a little bit, what does shrivel mean? Just
Yeah.
you can just understand what the problem is talking about. But then you have to go back and find out, okay, what type of problem is this? Is this a
Yeah.
division problem? Is this an addition? And so I would just focus on what type of problem is.
Yeah. But that's what I'm saying. I think with the extra information, like mango papaya punch. I'm like, or mini popsicles. Do we really need to know that they're mini popsicles? Do we really, you know what I mean?
No,
There's,
you would cross that out. You would just
yeah,
know that that it's all about sets of 10. You have 43 of something and you have to
yes,
put it in sets of 10. And that's all you really need to know.
yeah, that's how I would, because that's how I would position the word problems.
So you're saying that too much wording can distract them?
I think so. But
Okay.
that's how my brain is. My brain is a little bit more simple.
Okay.
I think minimize the amount of I try to minimize the amount of information.
Hmm.
And maybe they're doing this is because they have to get the kids to learn to minimize the amount of information,
Hmm.
right? So that could be the other flip side. Well, let's give you more information and you try to figure out what you need and don't need.
Yeah.
You know, there's like, it's a catch. It's a, you know, you can work both ways.
Okay.
Yeah. So I'm not saying it's wrong. I'm just saying that it's really verbose, but it could be that they're trying to get the kids to filter that out.
Yeah, it could be. It could be.
Yeah.
I mean, it's just like reading a passage. You need to understand what they're really talking about and be able to
Yes. And yeah, exactly, to
infer,
discern it. Yeah.
discern it and infer and to be able to answer the questions that
Yeah.
they have, with that passage. So it's kind of like the same thing.
Yeah. And I've always hated stuff like that. What do you think is gonna I've always hated it. Just as a kid. I've because I just want to get to the point, you know, but I do know that it is needed. I just don't know. I just don't know how to do it.
Yeah.
So
Well,
okay.
yeah, this has been fun.
It's
So
always fun. I do appreciate it. Is that I think that's it. Oh, do we have one more? Banana tree?
is that the other one?
Yeah, that's the last one from last week. And then we have these ones, but these ones are good, right?
Yeah. Yeah.
Okay. So this one is the last one, which is the banana tree grows 20 feet in height in 1 year.
Oh yeah. Okay.
20 feet. So 20 feet in 1 year.
Oh yeah, that's the one that threw you off, right?
Yeah, because I was thinking per year, but it's not. It said 1 year. So see, I even wrote it per year. It's not supposed to be per year. It's supposed to be in 1 year. That's the difference.
Okay.
So in 1 year, that's what it grew. But then it only grows half in the next year.
Hmm.
So half, we need to know that it's divided by two. That's what half is.
Hmm.
So we know we're going to do 10 feet because two take away 20 is 10.
Hmm.
So we know that this is the difference. We have to add the two together. 20 feet plus 10 feet is equal to 30 feet.
Oh, that's easy on the abacus.
Yeah.
Mhm.
Yeah.
And you probably don't even need to do that on the abacus if you don't want to.
Yeah, exactly. Because by then the kids should know that, you know, if I want to add the two and I add the one, I know how to do that.
Hmm.
Right.
Yeah.
So yeah, ideally they should know what their how to decompose their numbers.
I see. Yes. Yep.
Yeah. So
Is okay.
yeah.
All right.
Yeah.
That
That's
was a lot easier.
yeah. Yeah, but again, I have to reflect on why I got tripped up. So it said 1 year and not per year, because per
Yeah,
year
yeah,
is
they
different.
didn't have her. They just had 1 year.
Yeah. And that's where my reading skills are not as strong.
Okay.
Because I have, and that's why I like reading, I love reading, but to actually sit down and like digest everything that happens, it's like, oh, okay, I got to look at each word.
Hmm. Yeah. This has been very helpful.
Yeah, it's always a great conversation. We always go on different tangents.
A little bit, yeah, it's a little bit quieter. My son's playing with a friend outside, so it's a little
Oh
bit
yeah.
quiet.
But it's interesting, like to be able to break this down, like I find it fascinating and I don't have people that I can like around me that talk about like this like I would like to. And I like to talk about it and in depth about it because it's just fascinating on how to project it, and how to teach other people for it.
Mhm. Yeah.
Because I feel like it's underrated. It's underrated. We just assume that the kids are just gonna we just assume that we all know this, but it's not. I think if we broke it out to the way, why is mainstream doing it this way? It's because they want them to see the amount of numbers.
Yeah, yeah, I can see that. I can see that. I mean, it makes sense.
Yeah.
But it's also, I mean, anytime you're learning math, it's a process and it's something that you have to keep on going over and over. But um, yeah, I don't know. It's just not what I grew up with, and math is always changing. But what doesn't change is um this tool that you have here.
Yeah. Well, I have to go do some research. When did Japanese made the tool? That's what I got to figure out. Because I didn't realize that Chinese did not use the math facts, the fact families.
Oh, they don't?
No, they don't. They add up, which is crazy. So so now we're on another.
Well, I think it's cool to be able to um, learn how math evolved because they talk about the Arabic, the numbers. You have the Romans that use
Yes,
the Roman letters
Roman numerals.
so yeah,
Yeah.
so just the history of math and how it evolved around the world. I know it just gives you, appreciation of. So I don't know, maybe just knowing a little bit of history, but see, I don't know. Right now we're all about learning how to add, subtract, multiply. And then I mean, and then you have geometry, or you have all these formulas, like you have Galileo and his formula and buoyancy and stuff like that. Uh,
Yeah.
and just how math has been incorporated in science, and so it's just interesting.
Yeah, what I was reading up is the concepts that we're doing math now has actually just evolved recently. So you're right. It is always evolving. There's this one where there's this game, the Mario Kart or Mario Brothers. I can't remember. But there was this one person was talking about how they were talking about sine and cosine. It's a calculus thing, sine cosine. And so the way the first person that did it, it made it very clunky to understand how to do sine, cosine, or tangent, whatever that specific formula. And then now, just recently, they were able to make it more efficient because they have a better understanding. They made it more efficient that now the program can run through a browser as opposed to before it had to run through a console. And they were just saying that it's like 100 times faster now than it was when that concept of sine cosine came out. Did that make sense?
Never heard of that.
Oh yeah, it was just this
I've heard cosine, and I know a little bit of it because that's going into calculus, isn't it?
yeah. So yeah, and he was just talking about how changing the formula differently, like a little nuance, it will just change the way the whole equation will function, and it'll just be more efficient. And so I feel like that the abacus Soroban method is the efficient way.
Yeah, it makes it a lot easier for adding and subtracting.
Yeah, but I have to go back and see when it was formulated. So like in Chinese, Chinese abacus has been around for centuries, but what they do is they count it up. So we have 7 on the abacus, 5, 6, 7, and then we had to add the 9. Well, what they do is they count 3, 1, 2, 3. Because this is here, I have to remember 5 plus the 5. Now we have 10, right? So we have to remember to add the 6.
I each time I would talk to my older children and show the abacus, and I would go, okay, what's 6 plus 7? Well, you have 6 on the abacus. They would go 7, 8, 9.
Yeah, they count up.
They would count up automatically until you
Yeah.
told them that, okay, well, really, what you do is you have 6 plus 7. Well, you have to add in that formula. In other words, you have to go over and you have to add the 10, and then you have to minus the 3. And then minus the 3 is minus the 5 plus the 2. And that gives you 13. You have to balance things out. You
Yeah.
can't just count up, at least on this abacus, because there's only 9 beads
Oh,
there.
yeah. Yeah.
And so that's what they do. They would just add, you go 6 plus 7. Well, then they go 7, 8, 9.
Yeah.
Then they go 10
Yeah.
or something.
Yeah. So 6 plus 7. No, 7 plus 6,
Mhm.
right? So this abacus, you could do it. Add the 5, add the 1. And then you see this is 13.
Yeah. Because you have enough beads in there to do that.
Exactly.
So
Exactly.
how far can you go before you have to go over to the tens place then? So like, what if you did 7 plus 9? No, 7 plus 8.
7 plus 8.
Oh, it's still worse. Oh, so that's about as far as you get to go is till 8. But so
Yeah.
7 plus 9, you have to
Then you have to count up. Then you have to start counting up. So 7 plus 9, right? You have 3. I have to know that 6 take away 3, 9 take away 3 is equal to 6. So then what they do is they move everything over. So this is 10. That makes it 10. I have to remember that I still have to add the 6. So they count up as well.
Oh, wow. Okay.
Which is interesting. And that's why I found it fascinating, because I thought the Chinese abacus actually did formulas, but they don't. They actually count up.
Okay. So then obviously, I mean, there's lots of people around the world that count up then.
Yeah, well, there's a lot more people that do the modern abacus now. This is a modern abacus, the Japanese soroban, they do it. So
So
here, if
you
I
say more people outside of the United States use the abacus more than those that are in the United States? Is that what you
Oh,
basically?
for sure, because there's abacus competitions in India. There's like an abacus school like every corner. There's a bunch of people. There's a couple of Africans, African abacus teachers, and they follow me, and yeah, and they have a full class. Their class is like probably 30 kids, 40 kids, and that's only the one that they show. I don't know like what else, but like for where I am in LA, we might have maybe 50 kids in my learning center, in my brother's learning center, and I only have 2, 3, 4. I only have 4 students right now, and you're included. It's hard to get the word out.
Are they
I,
better? Are most people outside the United States, do they have a higher concept
Math?
of that? Yeah.
I think so. I think so, because they said that Americans are the like the worst in math,
Okay.
right? And it's not because yeah, and it's because I think that we have a lot of strategies and a lot of memorization.
Okay,
So
that makes sense.
yeah, and so like yeah, so when I was thinking about this, like when we want to make a 6, we want to get a 4, but to get the 4, we have to take it from here. We have to take it from the 7, but we have to break this apart. So to break it apart, I only need to add this 4 right here. 1, 2, 3, 4. So that's why this 4, this would we have to trade it in. I have to add the 1 here and then take the 4 here. That's why you make 10. That's why you have to take away the 5.
So maybe we make, yeah, I don't have enough knowledge to know why US is teaching the way they have,
Yeah, exactly. I don't know either. A lot of what I do is just speculation.
Okay.
Yeah, what I say is just a lot of speculation. But like, the Asian, they were talking, like, I was listening to Malcolm Gladwell for a while, and he was mentioning how the numbering system in the Asian countries are more succinct. So when we talk about this number 3,748, we actually say 3,748, right? 3 in the thousands. But in America, in English, right, we actually say, some rent like 18. 18 is not really a 1 and an 8. So yeah, it's just interesting on how, like, even the language itself, English is a little clunky, but it's one of the most popular most popular language. So yeah, so what I do, it's just more speculation. Like, I haven't done any research behind it, but there are studies that show that American kids don't have a strong grasp of math. It could be that that there's anxiety behind learning math.
Yeah.
And
Well, I'm hoping as I'm showing Abram that there isn't really, so what it sounds like is that you taught your children both ways, and then they eventually they just, because, and plus you started at such a young age, um, did they pretty much automatically use Abacus over, or they were just able to tell the difference and then use what they felt worked best?
they could tell the difference, right? And sometimes my kid, because the problem with Abacus is we cannot show our work, right? We just show the answer. So some of the work is like, draw a mountain, math mountain. Here's my math mountain. If I did 7 plus 9, you got to do 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. You know what I mean? So that's what they had to show their work. But then um I don't know. They were able to discern between the two, but they can use the abacus to double check their work. That's what they did most of the time, is they just use abacus to double check their work.
I see.
But because my kids went to public school, they still had to follow what the teacher said, because if they didn't, they would get a bad grade, or they would get a bad report. You know what I mean?
So you just
So
kind of helped them when they came home. So when they came home, you would just help them, or they would just automatically grab their abacus to just check the answers.
they would just automatically grab whatever they had. They actually, I don't even think they added. I don't even think they did math homework at home because they were already done.
Oh, you were able to do it pretty quick.
Yeah, yeah, and I know that.
You made the foundation for them.
Yeah,
I
yeah,
see.
and because, yeah, like, I mean, don't forget, like, my when my kids knew their multiplication, they were in what, grade, let's say grade 1. But when in mainstream math, they don't teach multiplication till like 3rd or 4th grade.
How far high up did they know their multiplication facts? All the way
They
to
only go up to
9?
they only go up to 9, but they did like 3 digits times, 4 digits.
And what grade were they in when they did?
I think they were in grade, maybe they were in grade 2.
But they knew all their multiplication facts by the time they were in 1st grade?
Well, they had to, because when we start doing multiplication, we just keep practicing. So when we do 23 times 7, you need to, or that's anyway, 23 times, 23 times 7, right? They need to know how to get 7 times 2 and 7 times 3, or else they couldn't do this. And that's right after understanding your two-step equations. Because we go hand in hand. After the plus 10, you're going to know how to do your multiplication fact of 2s, 3s, 4s, and 5s. After the two-step, you need to know 6, 7, 8, and then 9.
Oh, okay,
Be-
okay.
because the curriculum that we had was like 16 weeks. And so every 16 weeks, the way we built the curriculum, but I felt like that this was rushing it. Some kids were obviously slower, so I felt like that this is too quick for them. So some kids took a little longer. That's why there was the additive cumulative addition.
Okay. Wow. Yeah,
But
I have to see what they're, because see, I know in the third grade, they're starting to do, yeah, being able to multiply by 2, 3, 4, and 5. And
yeah,
then they do a little bit of simple division. And then I think it's in fourth grade where you're doing long division.
yeah. And so, but I think the difference in Abacus is that it's structured. I mean, you should only work with, what you know, but it's also, there's a framework as opposed to just here's a bunch of numbers, have at it. You know what I mean? I
Yeah.
think mainstream, I mean, even the books that you see that you have, you notice that when you look at the numbers, there's no, there's a loose structure on how the numbers are being situated.
Mhm.
Right. Whereas Abacus is very specific to the number, like how to add a 10. There's only very specific numbers to add a 10.
Mhm.
Whereas in mainstream, you have to memorize your answer, you have to memorize your answers and how to get to the answers, as opposed to understanding the individual elements.
Makes sense.
Which is interesting. Like I don't know why we have to memorize 12 times 12.
144.
Yeah, but why?
I don't know. I just know that it's 144. Because
Yeah.
I know 10 times 10 is 100 is 100.
Yep.
And then no, why do I know it? I don't know why I know it because I remember.
Because we had to memorize it. We had to memorize all the way to 12 times table. But I don't know why we needed to. My question is why did we need to? We could do distributive property on this.
Mhm.
1, 2, 3, 4. 1 times 1 is 1. 1's a single digit, add the 1. 1 times 2 is 2, single digit, add the 2. Do it again. 1, 2, 3. 2 times 1 is 2. 2 is a single digit, add 2. 2 times 2 is 4. 4 is a single digit, add 4.
Yeah, that's a lot easier.
Right? But see, you know why though. You know why we do, right?
Mhm.
As opposed to memorizing. Like before Abacus, I didn't know why this was 144. I just had to memorize it. But when I did it through the Abacus, I'm like, oh, it's because there's a 2 here and then there's a 24 here.
Mhm.
Oh, you know what I mean? Like I can actually see it now. I can break it up 12 and 24.
Oh, I see. Yeah, you're
Yeah.
right.
See, that's what I'm saying. Like we've memorized it, but we don't know why. And that's what they're trying to rectify. Mainstream math is trying to rectify it. That's why we have to break it out. Why did we do this? We've always just had to memorize it.
I
But
see.
now since I've broken it up, I'm like, oh, I can just do that. So that's the same thing with 11, like 11 times 11. I know what 11 and then 11. That's why. It's not because we had that one strategy. You add 1 and 1, make this a 2 and then have a 1. Remember that one strategy?
I don't remember that.
Oh, okay. I don't even know how to There was a strategy where you add the two numbers together in the middle. And I'm like, oh, okay. But if I break it up this way, I could see why I'm adding the two numbers together. Because we have 1, 2, 1.
I see.
Yeah.
Well, maybe it's kind of like how you said, maybe well, I don't know. You mentioned about how in the adult book you're explaining how we isolate the known variable. And you said, well, maybe you just need to just show the kids that they just have to memorize it. So, and then maybe just show it. So maybe that's what we were back then. You just kind of memorize it. I'm not really sure. But then in the adult book, you kind of show us also how once you've isolated that variable, you're taking that formula and you're putting it in and solving the problem. And the formula still is still correct, or I can't say the word. It's just a reliable formula because each time you do it, it's you get the same answer. If you have plus the 5 equals, or sorry, plus the 4 is plus the 5 minus the 1. It's balanced on each side of the equation. What you do on one side, you do the same on the other. Maybe.
Yeah.
Sort of.
Yeah. I could see that. However, we were taught to memorize how to get the answer as opposed to memorize the process inside.
Yeah. Yes, that's what's different. And that's why it seems like it's a reliable way of, because you're seeing
The
how
inside.
the inside part of it instead of just, okay. And that's
Yes.
why you said, don't, what did you say? Marry the process and
Oh, yeah. Marry the process, divorce the result.
divorce the results.
Yeah. Marry the process because it's the process that we need to understand. We don't focus on the result. Don't focus on the result because the result will show after you do the process.
The results will speak for itself on that.
Yes. Yes.
Okay.
And it's
Okay.
the same thing in life, right? We don't want to, we all talk about the journey, but the destination, we all die. But it's the journey to get there. My life and my journey is different than your life and your journey, but it's the journey we focus on. So why don't we put that into math,
Yeah. Yep.
right?
Yep. Makes sense.
Yeah.
So, well, it's been great talking with you and going through these problems. And it's just, yeah, like I said, I really trust this process.
Thank you. Yeah, I'm hoping that I can get the word out and just kind of tell the world. My other tagline is I'm trying to show the matrix what abacus is.
Yep. Yep.
And yeah,
So
so
so did your adult book work? Did it pass for publishing?
oh, it did. It did pass for publishing, and I'm trying to get into my shop, and I'm trying to get some into my hand. This is what it looks like. But I didn't get a chance to put like graphics behind it.
Mhm.
But that's what it looks like. Oops. Oops.
Oh, that looks cool.
And it talks about plus the 5 minus the 5 plus the 10 minus the 10, and I talk about the two-step equations.
Oh, wow.
And then after this I'm going to start going into multiplication, and then
Oh,
the third book I think is going to be division.
okay. Like simple division or
Yeah, it'll be simple, and then it will transition to hard, and then I think there's going to be advanced. So I think I was going to have like introduction, this is basic math, and then I'll have like an intermediate math. I'm not sure. um yeah.
okay. So that's in your Amazon store too right now?
Yeah, Yeah, that's at the Amazon store right now.
Oh, wow. That's gonna be cool.
Yeah. Yeah.
Well, I just gotta
Um,
be a little bit more consistent and like I said in my notes, I said that Abram was able to get onto Beast Academy and just have him try to go back onto
okay.
uh
Onto my class.
yeah, onto your class. I think I would love to try to do, maybe one class where he could do with you, but I think he would be very distracted and just want to tell you about all of his stuff that he is learning at the moment and that he probably wouldn't focus on math. So I don't know. So anyway, yeah. So I have to just kind of go back at the very beginning and just go back to, just the very basics, because he barely had an aha moment with the, four, with the plus the four is plus the five minus one. I knew he had an aha moment because his eyes widened and he realized that when we did the one plus the four, he saw it visually moving.
Okay.
That's
Okay.
when I knew that he kind of had, but then I haven't done it for a while, so I have to go back and I have to be consistent. So my question is abacus something you should do every day slowly, or should I just have him do a lesson here 3 times a week, use it as a supplement and go with, because he has his other math, his mainstream math too. So how would you go and approach that?
I I would recommend to have him do a little bit like a page a day if he could do.
Okay, just a page a day.
Yeah.
Okay.
Um I do have this one student and I did say hold off till you get to the two-step equation
Oh, okay.
because he's learning to count up, which is great. But but if it's too much, um, yeah, if it's too much for him to process, because it is a lot of math if you combine the two together.
Yeah, they might get a little overwhelmed.
Yeah, yeah. And then they won't know, or Avram won't know which one to use when the time comes. Because right now, abacus is really easy and it's easy for him to just be like put it together. Yeah.
Okay.
So this one student I have, uh he's also he's being tutored, and he's also and the mom asked, well, what should I do with the next tutoring? I was like, if you can hold off for like a couple of months till he gets to understanding how to make a 10 and how to minus a 10, and then after that he can go back into his tutoring, which is like Singapore math of what sort. But what I try to do is I want to build a foundation for abacus, make it solid before we go in, because the abacus questions, the questions in abacus method is very specific.
Okay. Okay, makes sense. It's very
Yeah,
specific.
yeah. So you can try to push him forward. So instead of going back to adding the four, see what happens when he adds the five, with add the three, and then add the two, and then add the one. Keep it within the making of the five and see what happens.
Okay, so pretty much go through your book and and then because my thought process is always kind of have him practice the maze where you have the 2-digit, the 3-digit, and the 4-digit, kind of practice that. Um, and then have him do one of the sheets like those. Yeah, we just need to probably get through the book, and I just want him to kind of go back on there and just look at your lesson online and then just do the sheet. Um,
Yeah, the reason why I added the extra problems was to have him just practice it. So even if he didn't get the aha moment with the plus four right now, he will get it later on, because the whole book is all about the minus five, or the adding of the five. So
yes.
that's why if it's okay to just keep him pushing him through, because when he starts to practice, he will start seeing the pattern. Because this is only adding of the 5. Yeah. And then the next book is only minusing the 5. I did add a little bit of adding of the 5. I did add a little bit of adding of the 5, so he could see the difference. But again, I think there's enough for them to practice that they will really get that solid. And that's why the book is 100 pages each. About 100 pages. And then the answers are in the back of the book. And then it happens again, right? So through practice and repetition, I think he'll get it. So I think just push him through and not worry too much about solidifying the actual minus the 4 right now. Yeah. So here we have the minus the 3, and then I give you again minus the 3. And I think from here he will get it.
Oh, right there.
Not Yeah, if not here, right? Because the example questions are just 4, but he'll keep practicing, and then he'll practice again, and then he'll practice again.
I see.
Then he'll practice again. So that was the thought process of learning it. So that's why I kept pushing forward, and because it will become concrete, but it's that practice and keeping him engaged. Because if you keep going back, he will get bored.
Okay, so you're saying push forward, just do the next sheet, even though he might not get it quite, and then keep on doing it again and follow
Yeah.
through all the way through the book. Would you go through the book again, the +5 book again, or would you just get extra sheets?
I would go to the next concept, which is minus the 5.
Oh, so don't repeat the book over again, because then he'll get bored. He's already done all the sheets.
Yeah. Yeah. And the kids don't, yeah, the kids don't like to, they want something different all the time. So
Oh.
in the questions themselves, they will continue to repeat. So don't worry about, so even with the
You have
minus
a
10s,
review. You have a review in there.
it's part of this, it's part of the numbers. There's already reviews inside it, because that's
Yes.
how small the elements are,
Mhm.
right? So even when we did these questions, right, you had a little bit of, well, how do I add the 5? This is how I do it. You know what I mean? So
Yep.
even within the questions, you still need to review.
Okay, that makes sense.
So because we know the fundamentals, the building blocks, you're constantly reviewing. That's why I just keep pushing him forward. Even when we do the two-step equations, right? With the two-step equations, you still got to there's still that review. Well, if I can't do the adding of the 3, how do I add the 3? And that's what two-step equations are. It's the same concept, but just finagled a little bit.
Okay, that makes sense. So that's what I will do, is I will just keep on following through on On the book, yeah, because I kind of keep on starting at the beginning. I just need to go on to the next page, even if he
Yeah.
doesn't get it.
Yeah. See, even we did the multiplication, we still practiced plus the 5 minus the 2 plus the 10 minus the 7. We still practiced it. But it wasn't, but it's something different, right? But we still practiced it. Yeah.
So basically, start with the +5, just go on to the next sheet and keep on going until you finish the book, and
Yeah.
then go on to the -5 and keep on going. And then after that, just go with the +10s.
Yep.
Because it's going to take a little while.
Yes.
Okay.
Yeah. The thought process behind it was I think it was going to take like a couple of weeks or a month to do the +5, 2 weeks to a month to do -5, depending on how many worksheets you go through, right? And so each one of these was going to be like a month, let's
Okay.
say. So that was the idea.
Mhm.
And not too stress about it. Oh, it's probably here. Yeah. So that's what I would do. And I was trying to make it interactive so they don't get bored. But let's say he knows, let's say he gets bored after a few extra questions, after he practices and he gets a little bored, then introduce the -5 so he has something new to think of, because even in here there's going to be a review, but still continue if you could. Let's say you want him to review, do one page this and then one page that, you know what I mean? So it can be kind of interchangeable.
Okay, kind of like a spiral effect. Okay.
Yeah.
Okay.
But yeah, yeah, probably more like a spiral. And then when you feel like he's comfortable with the -5, then you can introduce the -10 or the +10. And then again, until he gets to all the way to 1 and you feel comfortable that he is okay, then you can start introducing the -10. Because the spiral will happen when we start doing the two-step equations, and it won't be so difficult for him to catch on the two-step equations.
Okay. Okay. Okay.
Right, because I think that was the one problem the kids were having with the class, was that we would teach the adding of the 5, we teach the minus the 5, we teach plus the 10, we teach the minus the 10, but then we never went back to teaching the plus the 5 minus the 5. So when they get to the two step, they're like, this is a lot harder than I thought. But if we keep the plus the 5 and minus 5 still in their brain, like in the forefront of their brain, then when they go to the two step, it will be a little bit easier to get into.
Okay. Okay. And is that kind of how your adult book is? Because your adult book is covering all 4 of those.
Yeah, but I did break it up and I did push it through. So what I did was I had let me show you. Let me see if I can find it. So here is a preview of the adult book. Waiting. Here we go. So you can see the adult book?
Nope,
Yeah.
yeah. You have to switch your screen.
Oh, sorry. I didn't say share yet. Okay. So in the beginning of the book, well, okay, so the very, very beginning, it's this book belongs to. So then we talk about how to read the abacus. So I'm thinking that the whoever's going through this is like ground zero. They don't know what it is. So then I teach you how to do the book, read the abacus. And then we talk about the place value, and then we have a little bit of counting from 1 to 0, 1 to 100. And then we do a little review of what the tens place is and the ones place and how it looks on the abacus. So this is about place value. And then I have the maze, right? And then you only get one. And then here is another maze, but it's 3-digit. And then we go into, I think, 4-digit. This is the reverse maze. So I give you the number and then you have to find the answer. And then we start going into how to move the beads. And this is just a summary. And then after that, I just give you the questions to add it. And I feel like that would be easy enough that we can go straight into subtraction. Again, just moving the beads. And then I do a little fun pixel art, try to find the answer. And then here's your color key, figure out what the picture is. And then we start going into how to plus the 5. When we add the 5, I find different ways of how to add the 5. So if I do 3 plus 4, notice that I'm going to color in the 4 beads and I have this 1 bead that's going to be taken away.
Mm-hmm.
And so I give you some review and then there is the subtraction. So I don't spend too much time. I just kind of push you through to get you the concepts. And then we start going into like activities. And then we start going into the +5, the +10, and then the -10. And then it's a lot more writing the formula. And then I give you an activity and then you can write the formula. And then here is the multiplication. Here's the word ladder and that's it. And then we start going into the -10s, again, activity. And then here's the framework. This is what we were talking about. So I added in the framework. If you have enough beads, this is what you do. I did it for adding and subtraction. And then here we do the 2-step. It looks a little messy just because it is messy. The 2-step is a little messy. And so I break it down and then I give you questions that are more 2-step. And then we do it again, more questions on the 2-step. And then we start doing multiplication and then the minus the 2-step and then more activities. I don't remember if this is 2-step. I think this is a +10 or -10s. And then I just give you more activities all the way to about like 80 or 90 pages.
Wow.
Yeah. So this is the preview of my book.
That's cool. I like how you leave the space for you to write the formula. And then of course, because we practice after a while, then we probably don't have to write the formula out.
Exactly. And then I give you answers.
That's cool. So so it's about almost 100 pages, not quite?
It's 109 pages, including the answers.
Oh, well, I like it.
Yeah.
I like
Thanks. And so then I think the next book will be multiplication. And then the next book after that would be division.
that. Well, okay.
So we'll see. I haven't planned it out yet. Because I feel like as an adult, we would get the concept a little bit quicker. But then after that, it'd be just like intermediate would just be more numbers.
Right.
So
wow, that's great. I will just, like I said, I'm gonna try to get him to get onto the video and just, have him watch it a little. One of the things I have to do is I'm like really task oriented. I'm like, you're supposed to use the abacus, and sometimes he just like wants to just add it. And so maybe I just should not be too, just remind him gently, this is an abacus class and you need to just visually use the abacus instead of being being over his shoulder. You're not using the abacus. You're supposed to use the abacus. So
I would recommend what you're doing is fine. Because the kids, because that's the one issue is that the kids already know it. So maybe what we need to do is introduce 2 digits so he has to use the abacus. You know what I mean? That's where this would come. We give you mazes to do that. That's what this is. No, that's not right. That's what this is. So instead of having him, and maybe instead of doing him 1 digit, I give you 2 digits and he has to find the path. Maybe we have to do that.
Well, I'm just saying, even general doing the simple stuff, he needs to still use the abacus. And so he gets frustrated with me when I see him writing down the answer. And maybe I would say, okay, if you write down the answer, fine, but you still have to go back and use the abacus. So he's not quite ready for this.
Well, no, but he is though, if he knows his +4.
Oh,
See, that's what I'm saying. So instead of having a single digit, have a double digit, but it's only adding of the 5. So this one is 35, right? This is 35,
yep,
30, 35. I want to add 4. Can I do it? No. I have to plus the 5 minus the 1. So he can't visually see it because it's not single digit, but he will be able to do it because this is a +5 maze. Everything, all of these questions that you see is all about +5.
Oh, really? And
Yeah.
that's an adult book?
This is not in the adult book. This was going to be the like level 2.
Oh, level 2.
But we can
Oh,
introduce it. We can introduce it earlier. So so my this is my thought. I was actually going to make this like grade 1 or grade 2 because grade 2 they start doing double digits, but I
yes,
still need
yes.
to show them how to make a 5, right? See? If I did 41 plus 20, the number's bigger, but if you notice, I just need to add the 2, add the 5 minus the 3. So it's still a +5 formula.
Yes.
So
Okay.
do you want something like that instead? I can give this to you.
That would be great. I
Would
still,
he?
I think he still needs to do the other stuff because he's not in the habit of doing it every single day. But
Okay.
that would be good to have so that he can like try one problem.
Okay.
You know,
So
I think it'd be good to have both. I just need to be consistent and having him do it every day. And it's kind of like having him sit down. Some things he'll just kind of like do on his own, but then every time when he comes to application, he's like, ugh, sometimes.
yeah. No, I understand that because I have a student like that. And you know, maybe he won't see the benefit until the questions get harder.
Okay.
How old is he again?
He's 8.
Yeah. So maybe it's because the questions are too easy for him. You might want to start him on a 2 digit.
Okay. Okay. We
But
can,
but you can still go through the 1 digit. I mean, that should be he should be quick. But the problem is he's going to mentally do it, and that may not be abacus way.
yeah. And so
So yeah.
what tips do
But
you have on that? Because see, the whole purpose of this abacus class is to have him learn that. He did, like I said, he did like the oh, what do you call it? The you
color by
remember
number.
no, we did the matching cards.
Oh
And
yeah, yeah, yeah.
he really, really liked that because what I did, and I realized I need to go and make more. But what I did is I just took the +4s out and I would put it and he would flip one over and he would find its partner.
Mm-hmm.
Then
Mm-hmm.
we went on the abacus and we did 4 plus 1. Or
Yeah,
no, sorry,
yeah.
1 plus 4 is plus the 5 minus the anyway, we did that, and that's when he had the aha moment. He can do the simple math where without
Yes.
the formulas, he can add.
Yes.
He
Yes.
actually does that pretty fast. He does that fine.
Yeah. Because he's 8, that we're struggling with the fact that he can do it mentally, like with the simple numbers. That's why you might want to start introducing him the 2 digits, but we still talk about adding of the 2 digits, but still adding of the 5.
Well, with these problems, I noticed that in the tens place, that's where you're doing the +5 formula or the
Well,
+4.
no, it's also in the ones place too. It's just a
Oh,
mixture. Like
oh, it's a
even
mixture.
here, yeah. So even here is a 24 plus 13. There's
Yep.
the +5 here. So it
Got it.
just depends.
Okay.
I try to put a mixture of the tens and the ones, but maybe that will it make him interested. So my one student on Sunday, 5. He's got a really good handle on like the numbers, but he doesn't know why. And he didn't understand why using the abacus was beneficial until he got to the plus 10s and he did the 2-step equations.
Wow.
So I
hard advanced. Okay.
Yeah, so what I did, I just kept pushing him through. I still said to him, do it on the abacus, do it on the abacus, and we would still review it on the abacus. But now I'm starting to get him to do 2-step equations with me. But when he goes home, because his parents don't have time, which is fine, when he comes to me, I make sure that we do it together. And then he starts to see the benefits of going through it. But I do give him homework, which is the simple stuff, which makes him feel good. Because if I give him something a little bit too much, then he starts to break down. Like I gave him oh yeah. So I gave him like a 3-digit and he was just like, this is too hard. And I was like, oh, okay. But if we did it together, he would see it. So it depends on how you want to work it. I don't know if you want to do it together and then he does the this one on his own. But with the but he would still have to use the abacus. Did that make sense?
The maze with the maze. Could you send me a copy of the maze one? The one.
Yeah.
That
this one? Yeah.
Yeah. Just that one.
Okay. Yeah. And you want it in this format? Because it's a little overwhelming.
Do you have something simpler in that?
I would have to make something simpler. I was just trying this out because it's 1, 2, 3, 4, 1, 2, 3, 4, 5. So it's 20 questions. And I made sure that you touch every box. whereas these ones, if you notice, it's 12, but I made sure you touch every box. So I can make it something like this. That would be easy.
Make something like that so it's not so many problems.
Yeah. See, that was the other thing I was wrestling with because I wanted to change the format, but I'm like, maybe I'll just do this a lot longer than I anticipated. Because people like this because it's not a lot, but it's not too much, and it's not too less. I don't even know if that's a word, but you know what I mean.
Yeah.
It's not a lot, but it's not. I don't know.
That would be fun. The 21, the 20 odd problems, that'd be cool for me. But yeah, I think that's probably, that would be perfect. But I think that'd be too overwhelming for him.
Yeah. And that was the one thing I was trying to wrestle with because I was looking at it, I was like, ooh, and it does take a while. Because when I was going through it, it did take a while to go through it. And some kids don't have that patience, which is fine too. Because sometimes it's just like, okay, are we done already? And I was feeling it too. And I was like, okay, maybe, I don't know, maybe for those people that are more serious, that I would do this as more of an intermediate. And then this one, I'd be my regular one. Because I think 12 is actually a nice number.
Yeah. Because they can do 5 and then the next time come back to it.
Or whatever. Or they just finish like ideally if they could sit down in one sitting, it might take them like 5-10 minutes to do.
Right.
So I can make this into a two double digit, but it's only going to be 2 lines.
2 lines?
Yeah.
That's fine.
And then and I can get that out and then give that to you and see if he likes that better. It might be better just because it's different than the single digit, because the single digit he'll be able to see it. But again, I would still recommend him continue to try to do it with the abacus and say it out loud. And that's what I did with my student. Is no matter, he could do this in his head, but I wanted him to say out the formulas and show me on the abacus. And so I would sit with him just to make sure that he does it. And then when he got to adding of the 10 and adding and doing the 2-step, he's starting to realize that, oh, this is why we need it, because the questions got a little bit more hard. Because the questions got a little bit harder.
I see. And I noticed on the other page, a couple pages back, you actually wrote the formula out on the, right there. if you go forward, yeah, somewhere you wrote the formula out on there.
Oh, yeah. It's over
Oh,
here.
yeah,
Or no. I know what you mean. I do write the formula out. This one.
yeah, right there. You wrote it out on there, on
Yeah.
May's.
Yeah. So that would be a thing. Maybe like I'd leave the extra room so then he can write it out. But then I would have to label it, write the formula out.
Or I can show him the card.
Or you could show him the card.
Yeah.
But he would still have to chant it or some sort. He would still have to do some sort of remembering. Or he looks for the card. Not you show him, but he looks for the card.
Oh, when he's doing the maze.
Yes.
So once he finds the card, then he uses the card on the problem.
Yeah.
Oh yeah, because the one that you're doing, well, no, 3 plus 2, that would be plus the 2 card. He would have to look for that one.
Yeah.
Oh, I see, because you're
Yeah.
doing the second add-in. Okay. Okay.
Well, it's not necessarily, sometimes it's not the second item, sometimes it's the third one, right?
Yeah.
So this one here, right? This one. So it's just it's just the number that we're adding to. He would just have to find the card for it.
I
But
love
then
that.
but then don't forget this is after the lessons. So he understand, so I mean, go through these lessons and then after that, then we go back to solidify the numbers.
Yes.
That's how I did it for that.
Student. Okay. Okay. I will do that. I'll have him once he realizes that, oh, so like the 9 minus the 6 plus the 4, okay, so you subtract the 6 and you have 3. Well, then you have to add the 4. Okay, which plus 5 card do you need to find?
Yes, exactly.
Ah, should I have them all out in a row and then he looks for it?
You that's up to you.
Okay.
Have him either, yeah, try different variations and see what he likes.
Okay.
Or, and or have him write it out, and or have him write out the formula beside it.
Okay. Okay. I'll do that too.
Yeah.
Okay. Cool.
Yeah. But yeah, I wouldn't be stuck on the making sure that he knows what +4 is. I would keep moving him forward because there is a lot of, because the concepts are so building blocks, you will always see it.
Okay. Just
If that
keep on
makes sense.
moving forward. That makes sense. I will
Yeah.
do that then.
Yeah.
Because yeah, he's getting bored with us doing the same sheet over and over. Just keep on going forward and things will start to click and he will see the pattern.
Yes, he will start seeing the pattern when you get to the bigger questions and when you get to more questions. Because even we would get bored if we had to see the same thing over again.
Yeah, makes sense.
Right. That's why I try to change up the questions. That's why I change up but the practice is there. Like I give you when I look at this, I give you a bunch, like 4 or 5 mazes. It's the same, right? But I give you a different way. I don't give you the same path. I give you a different path of how to get to the finish, right? It's not the same way. So it should be the same thing with learning and going through the activity. Because if you go through the same way over and over again, then what's the point of trying to find our way?
True.
Yeah.
I will do that. Thank you so much. I really enjoyed this time. So.
Yeah, not a problem. I likewise, I enjoy it too, and I'm so happy that we're able to have a conversation about it and continue on to be able to, you know, make it better for both of us and Avram as well. But I don't want him to be bored, right? And that's why I try to keep the videos short, so you just get a gist of what you're supposed to do, and then have them do the questions. But yeah, there should be enough, and I do videos for all of the worksheets. So if you get stuck, you can always use the videos to review.
Okay, yeah, that's what I probably do. So, okay.
Yeah.
Yeah, because I'm only in just the first phase, the first class. I'm not even in the plus, the advanced class that you have online. You have two classes, two online classes, right?
No, I have the one. I actually, yeah, no, you're right. I have two, but you are in the advanced one. I just added more, but I think what I need to do is I need to break up my classes into separate books. So I think what I was going to do is I was going to rearrange so you can feel a sense of accomplishment. So because you're already finished with the simple adding and subtracting, then that would be one quote unquote class. And then plus the five should be another class because it's a lot of videos. It's like 40 some odd videos. And it can get overwhelming and just so like it's like drudgery. Like when are we going to end? So I think what I want to do is every book should end a class and then you start a new class so you feel a progression.
Okay. Yeah, because you have about 100 and something videos.
Yeah, yeah. And then I got to do the minus tens, and that's going to be another 40 some odd videos. So I feel like it's just never ending. But I feel like if you just ended a class, you get a sticker, you get a congratulations, you completed, and then you can feel like you accomplished something.
Okay. So you'll be changing the class that you have currently. You'll be changing that up then?
I think so. It's either change it up or I create the new set and then just push you guys over to that new set. Um,
Okay.
do you ever go back to see what you have accomplished?
I haven't been on there for a while, and and
Okay.
that's why I sent my email to you and saying, each time I get Abram on there, he's like,
Yeah.
but yet we're still working on how to build the plus five, and then when he's on Beast Academy. He's only on there because there are certain things that he likes to do. And so I'm wondering if he would learn better with just the books.
Oh, okay.
Uh,
Yeah.
you know, and so I don't know what that would do for you because because I've become on, because I think part of it was because I was on, he's in the class. But I'm I'm gonna try the class and see how that works. And then if it doesn't work, I hope you would be okay if I didn't do the class anymore. So it's just things like that. I want him to I want him to go online and be okay with it and do it. But if he is gonna just like, not even look at the video, then what? What am I doing? But yet these concepts and this principle is so important. And I've really gained a lot, and I think he will gain a lot. And he, like I said, that aha moment. And I just need to be consistent and go on with his regular math, kind of like how you're doing your children. They were still in the regular math, but because they had a solid foundation, they were able to distinguish between the two, and then they sound like they've been really good in math. I mean, brilliant. So, and it's just a matter of being patient with him too. With so I'm gonna get him on, and I'm gonna say it's because the video's only a minute and a half. That's all it is. You know.
Is that a problem or is that a
Um. Well, yours is probably. I think your videos are fine. When he's on Beast Academy, they have a video where he's talking. They show you the solutions, and sometimes maybe that just seeing all that can be overwhelming. And then if he's
oh
and then if there's this one math problem where there's this fish, he's in a tank, and you don't want him to lose water, otherwise he's going to drown or whatever. And so he's so, oh, I gotta get these, I gotta make sure he doesn't drown. But then the problems are going too fast for him, and then he gets
yes.
it wrong. So then
Yes.
his anxiety level goes up. Um,
Yes. Yes. Okay.
so I don't want him to have that either. Um, but my thing is I need to be consistent and just do one page a day. I will do what you've said, where you just go through, just move on, okay? Because you will always have a review of it. It will come up naturally, and just keep on going. Um, and
What if what if you hold on Beast Academy? Because what are they doing?
it might be too advanced for him right now.
Yeah, that's what I was thinking. What if you hold off on Beast Academy for just a little bit and see if we can catch him up to like even going to uh the +10s and the -10s? Because you've been going on pretty good. Like you're on a really good speed. um
Yeah, me, but him, no. You know?
well, yeah. So maybe instead of that's just a thought. Like what if you hold off on the Beast Academy and just kind of push him through the Abacus? So instead of like maybe 1 page a day, maybe have him do 2 pages of math and then you're done.
Yeah, yeah. He
Um
just does.
yeah, and just have him just because yeah, because I believe that I give you enough practice that
Oh,
you
you do.
can just go through.
Yeah. And the other thing is, maybe I should just have him. Um, what I might do is order kind of like a set for me, and the one that he has, he can write in it and do whatever he wants in it. So, and that way I have a set for me too, and I'm just doing it by myself. So I might,
Well,
because
it,
that's
well, if you're, I mean, do you not like it printout? Like I like books. That's why I did the book, but there are printouts if you choose to.
oh, I did print it all those out, and I can probably just spiral those extras that you have on the
Yeah.
online, and I did do that.
Oh, okay. Yeah, I like books. I like the feel of the book. I like the way the books are organized. And so, yeah, I understand. I was just
Yeah,
wondering. But
yeah.
yeah, so yeah, 2 sets are good too. What else? But yeah, if you could, maybe hold off until you get to the -10s. So you have them push through to the plus the 5, minus the 5, plus the 10, -10. It might take them, I don't know how fast you'd be able to go. Maybe it takes them like 2 months to finish everything.
Hmm. Yeah.
And then see what happens. Or you keep with the Beast Academy, but you have to curate those questions.
Hmm.
And I think that's a little bit more time consuming.
Well, Beast Academy, he only really needs to be there on there like once or twice a week, and just taking it a little bit slower with him, because he really likes the comic book part.
Is that
He really
reading?
enjoys that. Yeah, it's reading and understanding the concepts of math in there. And so he really, really likes that. And that's why having books versus being online, I think he caters a little to a little bit more yes and no. So what
Okay.
I'll do is I'll still have him go online, and I'll just kind of give you some feedback of how he acts on there, and
Okay.
then just continue to do the books with him, because right now I'm not very far. I'm on the +5. I'm probably on just the fourth or fifth page.
Yeah. And I saw that and I was like, huh. But you as a student learning it, you're like pretty far along. Like you're going all the way
Yes,
to multiplication now. So I was surprised that he is as far back as he is. Because I
he is very
didn't,
far back. Yeah,
yeah.
he's not very far on it. And so learning the verbiage and knowing how to teach him, and um but yeah, that's just what my struggle is with him right now.
Is it maybe I have to organize the the class better?
I like what you suggested. Do I okay, so like I maybe showing how the mazes work, because that's part of learning how to read the abacus. Maybe putting a video on how to do that, and then they can just go to the mazes, and then you have your simple problems, and then you have your +5, and then break it up, because there's like 136.
Yes,
Is it 136 or is it 100 and I don't
it's
know,
a
there's over
lot.
a
It's a
lot.
lot.
Yeah. So yeah. but at the same time, they're not very long videos. And then you told me that I don't necessarily have to do all of the sheets, just pick and choose.
Yeah, yeah. And so, but the one thing is I wouldn't have them repeat
Don't repeat.
because
Okay. Move
because
on.
it would, yeah, move them on. I mean, only repeat if he has the answer wrong. Um, but if you're
Okay.
worried about the concept, he will get it. It's just he just needs to get we just need to get to a point where it matches his expectation to use the abacus, I think.
Pork mouth.
I will try that. I will try that. So
Okay.
try
Okay.
that. How
Yeah.
much do you charge for a lesson online?
For so my lessons for me personally is 30 to 40 minutes. I think I've been going 40 minutes. 40 minutes once a week for two 200?
Yeah.
No, it was either 200 or 150. I can't remember. I think it
Okay.
was 150. I think it was 150.
I see. Yeah, that's out of my range. So
Yeah. But if you want to, if you want to continue, even though you have the books and you still want to have office hours, if you just want to continue with the $20 a month, that's fine too. But
oh yeah, even if he didn't complete things online.
yeah,
Okay, I wouldn't mind doing that. And then maybe what I do is do the office hour to leave it to about an hour.
yeah, yeah. But I mean, yeah, I don't know. I I'm still very new to this, but if I really think about it, you're getting a huge steal because office
Right
hours
now,
really, yeah, because office hours really me teaching you exactly what I would be teaching the kids. Well, no, I would be teaching the kids a little bit slower, but
right. Yeah.
so
So like I mean, we can do like yeah, I don't know if here on out would you want to do office an hour uh twice a month, or where I asking questions and things like that. What are your thoughts?
I haven't thought that far ahead. I'm just trying to get the I'm just trying to get it off the ground. And so I'm okay. I'm okay with what we have right now and the amount of time that I'm spending with you. If you're
It's been
okay.
so gracious. It's been so gracious. Um, so yeah, it's been very gracious.
Um
I've learned a lot. So
yeah, I'm okay for what it is for right now. When I think about it and depending on the time and stuff, I will reassess, but for right now, this is what I've got,
okay,
if that's
okay.
okay.
So the next time I meet, we'll cut it. We'll go to an hour.
It's I you know, if I have other things,
Yeah,
and it
yeah.
also so I mean I enjoy our talks. I enjoy that we can dive deeper, and I enjoy that we can I do enjoy it. So
Oh, me too. Me too. Me too. I just lose track of time, and now I know that it's like almost 2 o'clock.
yeah, I think we've been on for like 3 hours or 4 hours.
It's been that long, so
Yeah, it's
so,
been a while.
yeah. So
So, but I do appreciate it, and I hope it does work. It's just trying to figure out how to get children to do it. I obviously is a different science altogether,
it
especially
is.
since it is so hands off. Like if I'm so hands off, I don't I have to go through you. You know what I mean?
Oh yes. Okay.
So that's why I'm like kind of like because I don't know how Avram is, obviously. And so it's a lot about like how do you perceive it and what would I do in your situation? And so what I would do in your situation was I would push him through, but maybe hold off on the Beast Academy, like the actual arithmetic part, and wait till he gets to the -10.
Okay. Yeah, and they do lots of other stuff. I mean, they talk about geometry, there's
Oh
many
yeah.
different, yeah, there's more than one thing that they talk about. So
Yeah. Yeah. So get him to do like how to tell time, how to I don't know, what
oh
fractions are.
yeah,
Yeah.
they do all of that.
Yeah.
And so And I just got to realize that it doesn't matter what score I mean, if he has a 2, he's fine. And then if I want to go back over it, I can. And if not, we can move on. So
Yeah.
that's just thing. Mastering is just basically going through it, and then he'll pick up on he will see the pattern.
Yeah.
I mean, because I obviously have picked up on the pattern.
Yeah.
Because at the
But
very beginning, I had a hard time with the two steps. I was like, I don't get it. And I'd say, redo it again. I don't get it. Redo it again. And now I can do the 2-step.
yeah, I see. Yeah. Yeah. But did you do it again on the same question, or did you do it again with a different question?
No, I did it again on a different question.
Yeah. See?
I
But
was
if you,
able to see the pattern.
yeah, but it sounded like that you have different questions so you could see the pattern, but you have Abram on the same worksheet and it's just boring.
Yes, he's bored. Are you bored with the same worksheet, Abram? On the abacus? If I give you the same worksheet, you get bored? Yeah.
Not the same worksheet.
Not the same worksheet.
Yeah.
Yeah. So he
Yeah.
gets bored.
Yeah. So yeah, and that's what it is. Like you had different questions, he should have different questions as well. He'll see
Yeah.
the pattern.
You'll see, yeah. So I'll move him on, and then there might be some sheets that he likes better. And
Yeah.
then if I need to get a different type of sheet, because I mean, you're very busy, and I don't know how long it takes you to articulate, correlate a piece of paper. I don't want it to feel like you have to cater necessarily to him, but what you have is already a lot.
Thank you. Thank you. I try to make it a little bit try to make it as much interesting and interactive as possible. So we'll see. I mean, when the time comes, we'll see. How about that?
That sounds good. That sounds good.
Yeah. As you know, I'm very happy that I built this relationship and a bond with you. And just so I don't know where I'm going to take it. Maybe I might have to stop this and then get a real job or a job that pays more money. You know what I
Yes,
mean?
yes.
So, I
Yeah.
mean, but the whole thing is I'm trying to expand and explore and push as much of the workbooks and the worksheets, maybe more, maybe that's what I need to do. Maybe um instead of having an online class, I just push the books. I don't know. And then
Yeah.
I have videos with the books, but that would be at a higher price. So the books are $11 or $12, and maybe with an attachment of extra videos, maybe I do an extra $20, and then you get videos and you don't have to worry about a monthly subscription.
Oh yeah. Well, yeah, because it's you doing it online, and yeah, that would be cool.
You know what I mean? Because then you're not stuck with, but then you have the videos and you can go through it anytime you want, but you're not stuck with a subscription every month, and you're like, oh, I'm paying the subscription, but we're not doing anything with it. Because that's how I feel with the gym. How come he didn't go, like my husband goes to the gym, like, did you go to the gym today? No. It's like, why not? You need to go to the gym. So maybe that's what I'll do. So maybe instead I will break this up and provide videos. So I did have QR codes. I don't know if you noticed that. I did have QR codes for the +5, and inside it was just the beginning parts. And then maybe towards the end, if you want more videos, I can give you another. You just pay for the videos.
Yeah, yeah, and I because there are some people that have like a course to take a course could be um I don't know, $99 for a course.
Yeah, yeah, yeah. I don't know. I don't know if yeah, like I obviously I don't charge 99, um
You
but
know,
I
or
think
$75 for I mean, because it's like it's a 2-hour course. And so it's, I mean, $99 and you have limited access, that's really not that bad. I mean, especially if you're being taught, or maybe it would be $50 for just the +5s. And then you go on to the +10s, and it's, and then multiplication and division might be a lot more because there's just so much more entailed in it. So yeah, I mean that, yeah, and I think that was part of the reason why I'm paying $20. Abram's not doing anything on here.
Yeah, yeah.
But I figure, but you are giving me way more than the $20. It's so much. So, it has not been a waste. I want to tell you that. It has been very, very, it's been a blessing, it's been helpful, and I have gained a lot. And you've given me, trust the process, I think that's why I'm really drawn to us. And you are a great teacher. So
Thank you.
yeah, I'm serious.
Thank you. I appreciate it. I appreciate it. And yeah, I think I'm still trying to figure out how to make this sustainable. And so yeah. So we'll see. Like I mean, obviously it's about advertising and but I think my biggest hurdle is I have to introduce it to adults so they understand the benefits.
I've been understanding. I totally have.
Yeah.
And
Yeah.
especially when we did those word problems and we kind of broke it down and we actually used the abacus, because I mean, all honesty, when you're being able to do a word problem and then use the abacus, I don't know how many people would just pick up the abacus and just do it just for adding, but there's a purpose when there's a problem in there, or you have to figure out what it's talking about. Um, and the multiplication, doing that,
Yeah.
especially going through the multiplication table and you're visually seeing it,
Yeah.
it just clicks.
Yeah. Yeah. But what I'm saying is like my biggest hurdle is because nobody knows what an abacus is and the method to it, that it's difficult to envision why we would use it. So so it's like just the exposure of the actual abacus itself. So you were keen on it, which is good, and you were open to it. But there's a lot of people that don't even know that it exists. So my process is to be able to provide traffic and just to show like the basic how to count on the abacus and why it's beneficial to see it why it's beneficial to see the numbers visually. And so I've had been able to move incorporate but I notice a lot more people would rather do the books than go through an online class.
Yeah, yeah.
So I think maybe I don't do the online class. Or maybe I do a boot camp for parents so they have the tools to teach their children.
Yes. And then what you do is you offer that boot camp, I don't know.
Like $100 or whatever. And yeah. Plus the 5, minus the 5, plus the 10, minus the 10, and the 2-step equation.
Yeah.
Yeah. Maybe I do that. I don't know. So
yeah.
It's nice that you do tag on. It's nice that you're still part of my community. I don't know where I'm going with it yet, but if you're willing to stick on, I'm grateful that you do.
Yeah, I'll do that.
Okay.
So,
but yeah. So
I really appreciate it. So I'll stick on a little bit longer. I know I'll probably go a little bit shorter and a little bit shorter than 3 hours, but yeah, because pretty soon, probably this next month, I'm going to be doing a little bit more things with Abram here.
Right.
So,
and school's going to start, right? So
yeah.
You're going to start, when are you going to start school?
I'm going to kind of start a little bit of it next week. We've been taking kind of a little bit of a break.
Okay.
So
yeah.
I kind of want to get more in the habit of doing things with him, and that's just kind of things that I need to work on with him. So yeah.
Yeah. Yeah, yeah. And so yeah, my kids are going to start school in a couple of weeks, but that would just mean I have more time. But I understand because you're homeschooling, so you would be more limited on time. But for as of now, um
Yeah.
I haven't yeah, I haven't thought that far ahead what I want to do with the business.
Yeah.
Um so we'll see.
Yeah. Thank you so much. I really appreciate this. And it's been
Yeah,
wonderful getting to know you,
yes.
and yeah.
Yes, likewise. I'm so happy you're able to yeah, can I ask you what made you say, yes, I want to learn the abacus?
What made me decide to want to learn it?
Yeah, what made you decide to sign up for my class? Because I think that's my gap. Like I don't know what I have to offer, and I don't know what piques your interest.
I was looking online and then I just saw something about,
Okay.
because I've been researching a little other people's, other people that teach abacus, and then
Yeah.
I saw yours, and I thought, you know, um, I don't know if I'm gonna be able to answer that right now, but
Okay.
yeah,
Okay. Yeah, because I know I'm different than all the other abacus teachers. I know that. But I guess I just don't know what's intriguing.
I'll email you my story.
Okay. Thank you.
Okay.
Hi.
Hi, Abram. How's it going?
Great. One thing.
Okay. Yes.
I have I cracked it.
Yeah.
Practice what?
Acorn. You see it?
Acorn.
He doesn't see it.
No, I don't see it. Oh,
There you go.
what am I looking at?
That's an acorn.
Oh, yay. Are you going to eat it?
Well, it could turn into Nutella.
No, that's a
that's
hazelnut.
That has to be a hazelnut. That's an acorn. So acorn and hazelnuts are different.
Oh.
Yeah.
So, but yeah, let me text you. Let me text you my. Let me email my reasons.
Okay.
Does that sound
I'm
good?
pretending it's a ship.
Yeah. Thank
Okay.
you.
I'm pretending it's a ship.
Yeah. Does it float?
Yes.
Nice.
Yeah.
Yeah. Yeah. I think just trying to figure out either push the online or push the books. I'm not sure. So
Yeah. So I enjoyed so talking to you. So but yeah.
likewise, have a
Okay.
good day. Have a good night.
Yep. You too. Hey, thank